Hello. It's very annoying that blue light. Oh yeah, that's
Find the link. What does it say? It's in Dutch. I don't know.
finish stream.
Oh, okay. Okay, that's the link. Copy it then.
A live stream YouTube.
Yes. No.
Hmm?
No.
Yeah, that's possible.
Yes.
Do you want me to help or?
Oh,
That's okay.
oh no, I'm the test person now. Thank you. They took the fast train.
Yes, of course. I almost got lost. I didn't know. where.
Oh, really? Here in Amsterdam.
Yeah, it's strange here.
Yeah. Or not working?
It's almost working.
Oh, that's YouTube test.
Okay, yesterday it was fine. Just hope we don't have an issue with the internet here.
Yeah, it's there. Yeah. Hello. Hello. Here I am.
Yeah, I think it's fine. We should share
Nice.
what we need to share.
So you're now live streaming via YouTube.
Yes. No?
Hello.
No, but it's,
Oh, okay. Clear. On the one where the result is not possible. There is a feeling, but I'm not sure. Yeah.
Okay, so I think we can start now. Someone is still missing, but they will arrive. So good morning, everyone, and welcome to this workshop. I am Francesca Noardo from the 3D Geoinformation Group in the QDEV. And this year I organized, together with the others, the GeoBIM Benchmark project and also this workshop. You probably know from the amount of emails that you received from me. So this is the overview, the outline of the program. Good. So, technical help. Okay. Well, I hope it won't do it very often. Anyway, this is the overview of the program of these 2 days. And we will start with this short introduction on GeoBIM. Then we go to the hard topics today with 3D city models and building information models. And we will conclude the first day with a workshop session and a more interactive session for discussing all the issues that are around the GeoBIM topic. Tomorrow we will see some use cases, so GeoBIM applied to some use cases, some specific applications. And in the afternoon, we will have some presentations about georeferentiation of BIM and the conversion procedures, which are 2 steps, which are, of course, essential to reach the GeoBIM integration. I would like to spend one more word for the discussion of this afternoon. So, in the registration forms, we asked you about your expectation, your hope, the issues that you would like to discuss, and the hot topics that you feel, your feelings also about standards and integration and interoperability. And you all give very interesting answer to this. So mainly we would like to exchange experience, discuss about the issues due to the standards or to the software or to the data themselves, conversions and so on. And we also know that there are more challenges in GeoBIM. So for example, the lack of understanding or the lack of skills in both fields, what standards we should use. So we are always considering CPGMI and ISC, but a lot of standards are available for managing information, and Anna will give an overview about some of these in the afternoon. And some more points. So Claire organized this discussion in the afternoon. She's there. And she will lead this discussion in an interactive, nice way. And for this reason, we ask you to take notes also about these points during the day to further feed the discussion in the afternoon. And we printed some remind and hang them on the wall for later. So we can now begin with the GeoBIM topic. So what is GeoBIM? It is an integration. We can define it as the integration of 3D information systems, mainly 3D city models and building information models, in order to suitably support built environment applications with representation, understanding, analysis, simulation, planning, and so on. So we know city models are very useful, and later Tom and Balázs will tell you more about this better. We also know 3D. Oh, this is bad. We can get another one. That's fine. Could you try to put so, okay, this is really annoying, I'm sorry. I will stay here. So, also BIM are very powerful for managing building construction and management in a very effective way and support many applications related to this. But we also know that both of them miss something. So for example, 3D city models sometimes don't have a very detailed information stored in it. And also the detail and the levels of detail can be improved. And on the other side, with BIM, we miss sometimes the context, which is around the building. And we need it for some application. So for this reason, it's of course a good idea to integrate them, because both work can have advantages, one from the other one. So BIM work can have the context represented, and this can be helpful to test the building properties and also the impact of the building on the environment and the city, and the other way around. And the 3D city models can have advantages from the BIM integration, because they can have a better geometry and a higher level of details, more information that can be integrated, and they can be updated through this integration very effectively. So they could allow more accurate, for example, simulations and analysis. But it's not a straightforward issue. So GeoBIM consists in all of these aspects. For example, integration of data. That means that the data have to fit together in a practical way. So they need common characteristics for this. They need the common objects represented. They need the same compatible level of detail. And so we have to look at the data themselves for them to fit one into another one. It's not just a matter of conversion between formats. Formats are also important for interoperability. That's the second point. So it is about format and how they are managed, and standards and how standards are used. So not just to have the standard, but also how to use it properly and in a correct way, and in a way that is shared and nice for everyone. So sorry, we stop 1 minute and we try to solve this, because it's not possible to follow like this. Just a minute. One more try. So So we need interoperability in the sense that we need standards, but also we have to know how the standard work, how they are implemented, and how they are used in data. Third point, reliable conversion procedures in order to put in the end the data together, because for analyzing and for using them, we probably need them to be in one only format. And we have also integration of procedures. So BIM and GIS tool are very powerful, so we don't want to miss them, to lose them in the integration. Sorry. Okay. So we want to integrate data, interoperability, conversion procedures, and procedures themselves. For this reason, we try to address these two intermediate points in the GeoBIM benchmark project, because we wanted to investigate more the data interoperability and how standards are supported by tools, and also conversions. So this is the aim of the GeoBIM benchmark project, which was funded by ISPRS and USDR at the beginning of this year. The aim was the investigation of the available technical solution to support IFC and CTGML, because of course we know that they are there to foster interoperability, but sometimes we don't know if they are suitably supported, if current users are able to use them, if they are actually interoperable, or better, we know something from our experience of users and community, but we never had some evidence and some common ground to study these issues properly. So we tried to join our efforts all together and our skills and expertises, and we asked some external voluntary participants to perform some tasks and to test the software and the tools which are available in the procedures, and to report on this in order to put all of these together in a common base. We provided those data. So first, CTGML data is the whole city of Amsterdam in LLD1. It is a very heavy file, and it was also intended to test software and hardware performance together. Second dataset is the Rotterdam. It's a part of Rotterdam in LLD1 and 2 together. So we wanted to test with this the multi-LD support. And third one was a set of buildings that we had to generate in our procedural software in LLD3, because we couldn't find such an LLD3 data set from practice. So we provided this one to test LLD3 support. The ISC files that we provided were the Miran file from Sweden, which is a small building in order to test common software functionalities. A bigger building, the Uptown building from Rotterdam, also in this case to test software and hardware connected functionalities and performance. A building in ISC4, because the other ones are ISC2 Extreme, and we also wanted to understand how IC forwards. And finally, a set of geometries which were modeled on purpose to see how the different kind of modeling, which is in theory supported and foreseen by ISC, is actually read and interpreted by software. So Thomas probably will talk better about it in his presentation later today. Those were the tasks of the benchmark. So support for ISC, georeferencing bin, support for CTGML, and conversions from ISC to CTGML and from CTGML to ISC. We always try to care all of these points and investigate these points, so georeferencing, geometry, semantics, and what are the software functionalities with standardized data, which are not always working in the same way as the native format. So now participants just finished delivering their results, and we had a great participation, a large interest awarded with many registrations, and 41 participants delivered the results spontaneously, so they are not including the ones that are forced to make the test. And we tested this amount of software for the moment, and we are trying to integrate these numbers with testing more in order to cover the most part of the possibilities. The outcomes of this in the end of this year or early next year will be a list of tools or with guidelines and best practice to be used as reference by users about how to use effectively these tools with standardized data, and a report on the main issues, both due to software and due to standards themselves. So today, we will present the initial analysis that we made on the results for task 1 and task 3. And tomorrow we will see the other two tasks, so georeferencing and conversions. And we will also have a look in the first part of the day tomorrow at how all these aspects were addressed together in the use cases. So now I'm finished, and we can pass to the following presentation about 3D city models with Tom and Balázs, and enjoy the workshop. Sorry for this painful presentation before, but
Let's see if it works.
you need
I'm going to see it.
one information while they are loading they're changing the laptop, sorry. So from the web page of this event, you can also access the link to the streaming of this workshop. So if you want to share it with someone, it's there.
Yes, we have slides, and they work.
Yeah.
Good morning, everybody. My name is Tom Commandeur. I'm a software developer and a scientific researcher at the 3D GeoInfo group at the TU Delft. And I hopefully try to explain something about how we deal with and how we create 3D city models. And well, to take you through this wonderful job I've been doing for the last couple of years. And basically, I want to tell you about different kind of 3D models that you have and what you can do with a 3D model. So basically, what we probably all know is the 3D model that, for example, Google has, which is a 3D mesh. What they do is they fly and they take images from different angles, and from that different angles, you can calculate the location of a point. For the location of a point, you can use the pixel of the image, and from that you can reconstruct a 3D model. Basically what this is a whole mesh of a lot of triangles, and all the triangles are colored based on the color of the image that has been flowing. What you don't have in these 3D models is semantics. Semantics is basically what is an object and what is an object made of and what is the boundary of an object. So the geometry extent, the geometrical extent of an object. So basically what you can see here with all the different labels is that we can have plant cover, buildings, roads, water, all of these things which are useful to know if you want to do something with the data instead of visualization. So right now it's relatively easy to reconstruct 3D models, not fully automatically, but it is doable. Cities like New York have it. We have a lot of cities in the Netherlands like Rotterdam that have a 3D model of the whole city as well. I have to say that mainly the 3D city models I have seen are models of buildings instead of models of the city. So basically it's only 3D building models of a city, which is something different than a full 3D city model, of course. What you see here is a lot of different models that are available, mesh models, but also on the bottom left you can see that we have a 3D semantical model based on geometries. Basically what is being said is the more realistic it is, the better it is. Every time I question somebody and I ask, what do you want in a 3D model? They say, I want realistic, I want photos, I want people to understand that they're looking at their own house. Then if you give a comparison, like we can make a full automated 3D model with consistent data, which you can use tomorrow for relatively cheap investment, or what you want, which is basically like 4 years from now, fully manually created and takes a lot of time and money to create, then still the people I talk to say, I want them really expensive, really nice, realistic model. But we say that the value of a 3D city model is basically in the data. It's not in the view that you see, but it's basically that it can serve applications that you can use the data to do something with it instead of only looking at it. Also, which is really important, is that it can be updated. You can maintain it and keep it up to date. The 3D city models that are created, they differ a lot in the creation because even actually the same areas, if you model it, if you take two companies, two softwares, two different people trying to model the same area, you will still have differences because of the acquisition methods. You have the applications that 3D models are being created for and being used for. You have different data formats, different data structures. All of this makes the same 3D city model areas to end up as a different looking and a different accuracy of the 3D model. So what are the problems in the 3D city models nowadays? From all the data that we gathered and the geo-validation website that we have on in the 3D Geo Information Group, we gathered a lot of information about 3D models that are available. We took all the open data sets that we could find in the world and we validated them. And basically the result is that none of them are consistent and none of them are fully geometrically correct. None of them are completely watertight and completely valid. So basically existing 3D models are non-consistent. Also, they are basically collected for one purpose. And in general, from my perspective, the purpose is viewing, and they can hardly be used for another purpose. For example, for simulations using the data. They often require a lot of processing before you can actually use it for something different. Or you need to repair the data, you need to add the attributes that you actually want to use, the data that you need to simplify it, because if you have a high detailed model and you're going to do sound modeling, then for example, the sound model calculations cannot handle the high accuracy. So you need to simplify the model as well to generalize it. So domain experts that we talk to and we did some projects on this, they actually take 70% of the time that they do on a project for gathering the 3D information, to make it usable, to make it watertight, and to be able to do their calculations. What you can see here is that there's a lot of different domains where they actually use 3D information, and a lot of the time goes into gathering the data and making it work. Our goal is to go towards 3D city models for smart cities, where you basically remove the whole idea of I need to make a new model for every single simulation, and it will take 70% of the time of the simulation or a domain expert to do the simulation. So how do we want to do this? The idea is that you have one authoritative basis based on an international standard. And this is basically what we are working on in the Netherlands, countrywide at the moment, in collaboration with the Dutch Kadaster, to create a 3D model which can basically serve a lot of the domain experts, so they know that it's geometrically correct, it's watertight, and that it's usable for their simulations. Of course, we also know that you can't create one model and serve all the different domains, but that's where I come in the next few slides. First, I want to explain to you what I have been doing for the last couple of years. I have been working on the software called 3Dfire, and that's what we use in the Netherlands to create a countrywide 3D city model, or basically a countrywide 3D model at the moment. So what do we use? We use 2D topography, and we use 3D point clouds, for example, from LiDAR. But what we use at the moment at Kadaster is to use dense matching point clouds, since we have yearly photos, and the LiDAR point cloud that we create in the Netherlands takes about 6 or 7 years to acquire, completely country covering. So that's why we want to use the dense matching on the stereo photos, because then we can have yearly updates on the data. So what we do is we put it into the software, and the software could create different domain outputs. So it's up to date, it's valid, it's application-specific 3D data, in our case for the whole of the Netherlands, and the output has OBJ, CityGML, CityJSON, and it's relatively easy to implement extra formats if needed. So how do we do this? So we take the cross-section of the 2D data, and what you see here is you see the horizontal view of all the polygons. All the black dots are the vertices of the polygons, and these polygons are topologically connected. In the Netherlands, we have a 2D data sets, which is country covering, which is topologically correct, which is the BGT, or it should be topological correct. And you will have a view like this. And what we do is we assign to each polygon type, we assign a class. We say if it's a building, water, road, vegetation, terrain, things like that. Based on that, we can go into the software and we can use calculation rules to make it 3D. So we have the 2D polygons. We overlay them with the 3D points. They're light gray. They might be not as clear as I would want them to be. Around all the vertices, we take a buffer of 1 meter. So not around the polygon, but around each vertex. And for each vertex, we're going to see which LiDAR points are within a distance of 1 meter. And if so, we are going to use that height to use it to calculate the height of that specific vertex. For every vertex, we use simple rules, for example, averages, or we use percentiles to calculate the height of that specific vertex. We do that for every single vertex, for every single polygon in the 2D mesh, in the 2D polygons. And only for terrain and vegetation, we add LiDAR points which are lying within the polygon. So for roads, for buildings and things like that, we only use them to calculate the heights of the vertices. And for terrain and vegetation, since you want to have a nice terrain model as well, we also add LiDAR points which are within the polygon itself to describe the terrain better. What you end up with is that you have gaps. They might not be that clear, but over here, you lifted the polygon of the road, you lifted that to a in this case, for example, the median 50 percentile, and we lifted the water to a 10 percentile. So the water is lower than the bridge actually is. So you will get gaps. What do? We fill the gaps with vertical walls. So these are basically the rules that you use to stitch all the polygons together to make sure that there's no gaps anymore. So you can see here that, for example, within the terrain and the forest, we can use an average of both. And we can use for the water, we can, for example, say the water stays the same because the water is flat. And if you connect the terrain to the water, then the terrain needs to be adjusted to the height of the water. And for man-made structures against man-made structures, for example, buildings, you will actually say that the building should have vertical walls. And there you add the vertical walls in the 3D model. Which you can see here that all the red patches are actually added vertical walls or vertical polygons. And that's what's actually making it 3D in this case. So this is basically the lowest level of detail that we can generate fully automatically without any manual intervention or additions. This is polygons and points in, you get a 3D model out. And for this, we are actually creating a level of detail 1, which is the extrusion of the building footprint. We are also working at next steps, which are LED 1.3 and LED 2.2 at the moment. I will show you later what I mean with that. For all these different modules, we have the level of details. The level of details is something which is introduced in CityGML. And in CityGML, what we describe is basically what is described below here in this picture, where you have LED 0, which is a flat footprint. LED 1 is the extrusion to a given height. LED 2 has a roof shape on it. LED 3 adds dormers, windows, and other outside furniture. And LED 4 adds the inside view with to the model. So you would say LED 1 is a simple block model. This simple block model can actually have a lot of different representations, because what height do you use for this 3D model? For this 3D model, you could, for example, take the gutter height of a building. You could use the ridge height of a building. Do you use the 2/3? Do you use half the height of a building? It actually depends on what application you're going to use it for. If you're going to do a shadow analysis, for example, the height which is in between the gutter and the ridge is the best height, so half the roof height. But if you're going to do a sound modeling, you want to have every possible sound blocked by the building to be calculated. So for sound modeling, the maximum height would be more usable. So how do you calculate it? Do you only use the highest polygon, highest points that fall within the polygon? Do you take a buffer? All of these things actually contribute to the different calculation in the actual height that you're getting in your 3D model. What we see is that often users do not even know that an LED 1 model has so many different options because of the way you choose the height. So for this, we have a description of the level of details, but there's no rules and no standardization on how to calculate this model actually. And you would say that level of detail 2 is more accurate than level of detail 1. A previous colleague of mine, Philippe Loyecki, has actually done research on this, and he checked if there's a difference between accuracy in the acquisition error, or in the difference between an LED 1 and an LED 2 model. And actually his results were really interesting, that the accuracy of the acquisition of, for example, a LiDAR point cloud or the calculation method makes more difference in the actual outcome of the simulation than using an LED 2 model instead of an LED 1 model. So that's a really interesting outcome that you would not expect, but basically most of the results showed that the accuracy error introduces more differences in the outcome than higher level of detail. which also means that a city model can be too detailed. And it's not always good to strive for the highest level of detail. As I said as well, that if I ask people, they always say, I want the photorealistic, perfect 3D model. But in the end, having a lower level of detail, which could be really affordable, quick to get, easy to use, could be way better for a lot of domain experts to use. So related to the application. We're talking about level of detail here. And for the BIM people that don't know that much about geo, level of detail is something different than the level of development in IFC. And I've heard that there's going to be more about this later on, so I'm not going to go into. 3D city models rarely are generated with an end goal in mind. Basically, the goal is we want a 3D city model, so let's create one. Preparing the different 3D data for the applications takes a lot of time. As I said, a lot of the domain experts take 70% of their time into getting and using the 3D data. And the data itself is really undervalued. You can actually do so much with the data in a 3D city model. The semantics are really important, and it's really undervalued in the 3D data field. There's a lot of errors in 3D city models, which are basically because of geometries, and these cause errors in the outputs as well. So getting a higher detail with a lot of errors doesn't really give you a better result in the outcome of your simulations. So 3D city models could be available, but they're really underused in their potential. So I'm going to go into for what you can use 3D city models. 3D city models in urban applications. Here we need semantic 3D city models. If you want to use it, you need to know if a building is a building, if a road is a road, and not just have a nice visualization and an image-ready picture. So you need to have an application-specific level of detail. You need to look at what do I actually need and which applications am I going to use with my 3D model to determine what kind of level of detail you actually need for your 3D city model. So what is important as well is you need to have an up-to-date model. When getting a 3D model, when creating it for the first time, you also need to think about how can we update it, how can we maintain it. Can we actually update it, or do we throw away this model and make a whole new one after 4 years, which is basically what happens now most of the time. It needs to be without errors, because having errors in your 3D city model as input of a simulation will give you errors in the output of a simulation. I actually had the same problem with a colleague of mine last week, which we created a super simple LED1 model, which he was going to use for computational fluid dynamics, and the meshing algorithm didn't want to use the 3D model, and it actually said that it had holes and it had gaps, while in the end this will not this is actually what shows why there's a need for really well created geometrical valid models. We are also working on a 3D nationwide input dataset for noise modeling, and this is basically because it's something that you can directly use, and it's an application-specific 3D city model. We referenced a nice picture that was created by Henk Kluiver and Tom van Tilburg. Tom is in the room as well. He's also working on this topic, and basically what you see here is that you see a building which is really common in the Netherlands, which is a building with a pointy roof, and you have a garage next to it with a flat roof. If you look at the 2D polygons that we have of the building footprints, this building actually consists of one footprint. If you are going to calculate an LED1 model out of this, you will just get one single height, which actually happens a lot, where the sound can actually travel over the garage, which is next to the house. What we are trying to do here is that this requires level of detail 1.3, which is basically a block model with an extrusion, but then split in different heights. So in this case, you will get the blue outline here, would be one block, and the blue outline there would be the next block. So you will get actual different heights in the two parts of the building. So besides that, what's really important is to capture the height of the terrain with lines by using as few lines as possible. So you want an as high detailed as possible model, but you want to use as less lines as possible. That's basically because the calculations that are being done are taking a lot of time, and storing the data takes a lot of storage. So you want to model as few lines as possible, which sounds easier than it actually is. Besides that, we have 3D city models for energy consumption, where you can model a building you basically have to model it in a different way, because you need to have the ceilings, the walls, the floors. You need to know what's an inner wall, what is an outer wall. You need to know the materials that are used, the insulation that is actually used, because this is all properties that you need to have before you can basically use a 3D model in energy simulation. Besides that, you can do flood simulations. For flood simulations, basically, the level of detail of a building is not important at all. If you would just have a block which has a highly detailed outline, it's more than enough. But if you want to use these models for flood modeling, the terrain model needs to be very accurate and very high detail. So also you need to have the semantics in this model for infiltration and permeability, because you need to know where water can actually go. And then, as I already said, we tried, or a colleague of mine is working on CFD simulations, and with computational fluid dynamics, you can actually do wind quality, wind, air quality, temperature, but also, for example, you can see how nice it is for a pedestrian to walk through a city. If there's a lot of wind or a lot of large heat zones in a city, this is not really comfortable to walk through. So these are things that you can really well calculate with the CFD model. But the requirement is that you need to have a 100% closed, valid, watertight model. Now I hope this will work. Yes. So this is a video of my colleague that she this is how she creates the 2D data set that she gathers. She adds the buildings, the terrain, and the water. And from that 2D data, you add the 3D point cloud. Within 3D Fire, you calculate a 3D city model. And you end up with the building heights. You end up with a completely closed terrain, which is topologically correct. And you end up with the LB1 result like this. Then what she does is that it's not that visible. She actually measures all the air around all the objects that we have. So you get a lot of triangles, and from all these meshes, she can do a step-by-step calculation from triangle to triangle. And you will end up with heat dispersion, wind dispersion, and you can, for example, see where you would have high wind gusts, or where you have a pollutant. If you have a highway in a certain area, what the pollution would actually be. From that simulations, you can actually use the simulations to change the 3D model, to change your city. And from these changes, you can actually recreate or remodel your city into something that is better for the urban environment. This was my part of the presentation. I'm going to hand it over to Balázs.
Thank you, Tom. So welcome from my side as well. My name is Balázs Dukai. I work as a developer just as Tom in the same group. And Tom, in the first half of the presentation, he presented what 3D city models are, what can you do with them. And now I'm going to talk about how you actually store them, how you can distribute them, what data formats are available. At least I'm not going to mention all of them, just a couple. Probably if you are here in this workshop today, you heard about CityGML already, or maybe not. So in case you didn't, it is an international standard for storing semantic 3D city models. So it describes, it has a data model, and it also has an encoding, which would be the actual file that you have on your file system. And although it's called CityGML, it is actually used not only for cities, but also for representing places in between cities. So we could model the landscape with it, provided that is actually above ground, because what CityGML doesn't model is, let's say, mineral deposits or natural phenomenon and that sort of stuff. But what you would find in a city, all the elements, you can use CityGML to describe it. Now, so 3D, as Tom explained or hinted already in the first half of the presentation, 3D city models is more than just visualization. Actually, this iceberg kind of illustrates it nicely, because what you see, at least nowadays, what most users see is these pretty fancy visualizations with textures and everything, and you see these demos from various organizations or companies showing their products and their data. But in order to make this data set useful, there's quite a lot of work going on under the water or behind the scenes that needs to be correct in order to make them useful. So, what do we mean when we talk about semantics, actually, or what do we when we talk about the semantic data model? So, speaking of a single building, I'm talking about buildings again, although you see, because that's actually quite easy to use an illustration point to describe the point. So the easiest way to approach is we have geometry, and then using the geometry we describe the shape of an object, right? And then we can use different kind of geometric representations to put together this object. So we can choose to model this object as a solid, and we can which would be, let's say, imagine a cube. So we know the interaction between all the surfaces, or we can choose to use a different kind of geometric representation, like a multi-surface, which would be in this case just a collection of surfaces. And now, okay, we have the shape. We can describe it how it is in the space, but then we have to label the parts. So we have to know, first of all, that we are talking about the building. Then when we go more into detail, then we need to know that we are talking about actually a roof surface. We're talking about the door, the window, and a building part. A building installation would be, because it's something that we attach on the top of the building. So, and these are the semantics, and they have a hierarchy. You can put them in a tree structure, so to speak, to describe that, yes, indeed, this door is part of this wall surface, and then the roof surface and all these other surfaces are actually part of the building, and so on. And the building is part of the city, and so on and so forth. So now, I told you that we can decompose a single object, but we can do the same thing actually for a whole city. And using these semantics, using these labels, we can subdivide the whole city into parts. We know that we have vegetation areas, we have the road surface, we have water, we have buildings, and all other objects that you encounter when you walk in the city itself. So there are quite many of 3D formats actually available. Some of them are semantic formats where you have the description of these labels together with the geometry, and some other standards or formats are purely geometric or graphical standards, let's say. We use these when we only want to transfer, or we want to only want to work with the geometry of the objects, and some cases that's actually more than enough. For example, For example, for how to say, the gaming industry, I wanted to say, they don't really use actual semantic standards, but also at some point in the visual or simulation pipeline, we discard the semantics from our objects, and we only use their geometry to simulate that wind flow, because the wind doesn't really care if that's a wall surface or it's a roof surface. What matters if there's an object there or not. Then, yes, and as Tom described, semantics are pretty important. I only wanted to add one point to that, is that so semantics makes our life, because also Tom said people spend about 70% of the time preparing the data and validating and repairing the data, and that is where the semantics part come into play, because they help immensely in this data preparation part. They save me a lot of time for finding the roofs, surfaces of the buildings, because I'm only interested in the roofs or the walls or the ground surfaces and such. Now imagine if I don't have these labels on my buildings, then I have to write algorithms to extract the roof parts every time I work with such a city model. And then for all these different kinds of applications, this data preparation is necessary in the beginning to filter out or discard what is needed and what is not needed. Now coming back to CityGML, CityGML is comprised of modules, so to speak. We're talking about thematic modules. We see we have the bridge, building, city furniture, land use, and tunnel modules. They describe these different aspects or different parts of the city itself. And then on the top of all these, we can add appearances and other parts. And there's a core set of rules and elements that we can use the core CityGML standard for. And then if that's not sufficient, especially when we go to the applications part, the application domain, then we need so-called application domain extensions. And we have those for noise simulations, for energy simulations, and they are useful for storing data or storing results from these simulations back into the 3D city model and sharing these results with other people. Now, how does actually this data model look like? We have a city model that is, let's say, the larger entity, which would be a city itself. It actually depends what you have in your file, what the area you want to model. And then city model is composed of many city objects. And city objects can have different types. These come from these modules that I mentioned before. So we have transportation, tunnel, vegetation, and then each of these features, so with each of these parts of the city model, city objects, they can have geometry and they can have their semantics, and also different level of detail, each of them. Now, as I mentioned, CityGML is actually, it has two parts. One is the data model, which I have described, and the GML encoding. The thing is, both of them are called CityGML, and it's actually a bit confusing because they are not the same. So when we are speaking about the data model, we are talking about the theory, so all these things that I just described. And now when we are talking about the GML encoding, we are talking about the actual file that you receive, and it is encoded in using the GML language, coding language. And in fact, the GML part of the story, makes working with CityGML a bit complicated. I'm not sure how many of you have experience from the user side or from the developer side, but this is the GIF we actually show nowadays in every presentation of ours, to be honest, because this describes quite clearly how we feel when we receive a file and we have to work with these data. That is because in CityGML, a person can describe one thing almost, well, not an infinite different kind of ways, but quite many different ways. And as a software developer, if I don't if I have to account for all the 25 possibilities to encode a polygon, to describe a polygon, that is insanity. To develop a software for describing a single polygon 25 different ways, and then when we go to 3D, then this number of variations explodes. So that is why we thought, okay, the data model is nice, we want to keep this, but let's discard the GML part. And what would happen if we would use a JSON-based encoding? So using JSON as a more leaner description or data format instead of GML. So in that case, we developed CTJSON in the last 2 years, I think, more or less, year and a half. That's how it started. And then now we say there are two encodings for CTGM, for the CTGML data model. One is GML based and the other one is CTJSON. And you can visit we have a website on ctjson.org. And with CTJSON we have a few key ideas or key aspects that we were very strict about since the beginning. And the first of it is simplicity, because we say simple things should be simple. And we ourselves, most of us or almost all of us are programmers in the group. So we wanted a data format that's actually good to use in a software development setup. So it is it is easy to write software for, and it is easy to maintain, it's easy to implement. And then now we are at version 1.0.1. That means that all the CTGML modules are mapped to CTJSON. These are, remember, the modules of the tunnel and the bridge and the buildings and such. We have, thankfully to another person who is not working in our group, but he wrote a full conversion between CTGML between CTJSON. So in case you have a bunch of CTGML files and you are convinced after this presentation and this is like, yes, I want to convert all my files to CTJSON, then you can use that tool. It's called CTGML tools, by the way. You'll find it on GitHub. And it's possible to write these extensions. So for the different kind of applications like noise simulation, energy simulation in CTJSON as well. And we have a bunch of software on our list already that support CTJSON. So starting from creating 3D city models with 3D for example, visualizing these models, we have an online web viewer practically where you just drag a file into the browser and then it shows you what the contents. We actually have two. I'm looking at status, but so we have one at the viewer.ctjson.org, and then I think the second one is coming up soon. Then we also have local viewers. One is called Azul, which is based only for Macintosh. And then we have a plugin for QGIS. And we have a plugin for Blender as well. Blender is a 3D modeling software used for I don't know, in the games, making movies actually they use that sort of stuff. We have a command line software called CGIO, which stands for CTJSON input output, and you can use that for reprojecting files, checking what's inside to have a quick peek what kind of elements you have, how many vertices, faces, objects. You can combine city models, you can filter objects out of the city model, and so on. And exactly these weeks we are working on a reader for the FME software. So if everything goes well, it will be part of the next release. Although I cannot promise anything in that side because I'm actually not part of the contract. So now we converted some files from CTGML, and we've seen that if we use CTJSON, the format itself, then we achieve on average a 7 times compression factor. So CTJSON files CTGML files tend to be quite large. Often they are multiple gigabyte size. And first of all, it's a bit problematic to send over the web you need to upload the key, you need to wait for the upload and download. So smaller file size it's nicer in that case. It also makes it quicker and easier to read into any kind of software because you have to go through a smaller amount of text and stuff in your file, basically. And now, Tom also mentioned this already briefly, but I wanted to actually drive the point really that errors are very, very common in 3D city models. And most of these errors are, or many of these errors are actually not visible when you open the file because we're talking about very tiny, couple millimeters differences where vertices don't meet, and we have a hole, and you look at it and you don't notice. And the worst part of this is that exactly just he described in the example from last week, it makes it impossible to use these city models in simulations or practically anything. So maybe you use some specific software that you creates this city model, and according to that software, the model is valid. But then when you export it, they send it to some other person, and suddenly the person cannot use it because at least there's no like universally accepted common description of what is actually a valid 3D city model. So we have in our group, my colleague Hugo Ledoux, he thought about this quite a lot a couple of years ago, and he developed a validation software which uses two standards, one from the OGC and one is an ISO standard to describe what is a valid 3D geometric object. And you can use this. We have an online validator tool, and you can use it to validate CTGML, CTJSON, but also OBJ for some non-semantic files. And it checks for a whole bunch of errors. And at the end, it tells you what objects are valid, which objects are invalid, what errors you have in your file, where are those errors in some cases, if it's possible to pinpoint them. So we did this study, and it turns out that all the files are invalid. Actually, that at least a couple of years ago that were online. And the problem with that is that also at this point, we don't have an automatic repair method. So once you receive an invalid file, you have two options: either throw it out and ask the person to fix it for you and deliver you a valid file, or load it into some graphic modeling software like, I don't know, Blender or Maya or whatever, and try to fix the little vertices. So you would need to snap the little vertices by hand if you can locate them, and that's just an insane process. So it's practically not feasible to do. So that's why if some of you, or if you are in position that you are accepting 3D city models or creating 3D city models and then releasing them to the public, please make sure beforehand that they are valid. So other people who will receive those files, they will be actually able to use them for something more than visualization. So I'm approaching the very end of my presentation for today. And at the end, I wanted to show you, we have a small website. It's sort of a curated list of openly available 3D city models. Especially, I wanted to point you out this part, 3D city models. We have a big list of open 3D city models. We always, whenever we receive or we hear about that this city or that city released their data as public data, then we add it there. We also have some CTJSON files that we converted ourselves. And with that, I would like to thank you for your attention, also in the name of Tom.
Yeah, you can do it.
So if there are any questions, then...
Yes, thank you, Tom and So, there are any questions about 3D city models and yeah.
I have a question to Tom.
Yes.
Please.
The accuracy of the LiDAR data is 10 to 20, 15 centimeters. So why do you use a buffer of 1 meter? to assign points to the VGT?
Have you ever overlaid the AHN3, which you're talking about, the LiDAR data set, with the 2D polygons of the VGT?
No, explain it.
I think if you see that, the answer is directly visible. It's most of the times it's aligned, but a lot of the times it isn't.
So where's the inaccuracy in the VGT?
There's no answer to that.
Okay.
It's either in the VGT or in the reconstruction of the AHN. Generally, you could say that the AHN is correct, but of course you are flying with a plane with GPS and you're correcting that towards a terrestrial measurement, which is then manually edited, updated. So, yeah.
It's accumulation of errors.
Yeah, specifically. And this is also not only for the Netherlands. So you have a lot of less accurate data sets in the world. So we wanted to be able to cope with that as well.
We have another question there.
I'd like to continue on this last question on accuracy of the AHN and the combined with the VGT. The VGT is, of course, designed as a 2D data set. So actually what you see is that the polyline indicates are on the borders of land use and not specifically on the borders of terrestrial features like great lights. What's your opinion on these features like topological topographical features in the landscape that are obviously missing in the VGT but would be in the AHN? Specifically looking at the dikes where you miss the actual shoulder of the dike because the VGT has its line segments just 1 or 2 meters next to it.
Well, the VGT does have these features. It is described that it is needed to model these features. The toe lines and the headlines of the lower bottoms and the top bottom parts of the dikes should be modeled. But the way it is described, as always, in legal terms, it says that if you have in a distance of 1 meter, a height difference of 1 to 4 with a ratio of 10 to 9, then maybe you should be modeling it. I think that basically the reason is that it's not modeled correctly, is that it's not written in a way that you can actually say that it needs to be modeled yes or no. And I think basically the legislation there is the issue. But the question is also, do you need to model them in 2D? Since it's a 3D feature, if you have a 2D data set, that's, yeah. Depends on what you would use it for. For us, it would be really interesting, but I see that for a lot of 2D use, it's not of any use.
It's just very fine using the top lines.
No.
Other questions? Yeah.
Yes. Question for Boris.
Yes.
I saw you are modeling semantically geometry and objects,
Yes.
but I was missing the functionality of the objects. To what extent you model also functionality like living or working, or because that's important for environmental planning.
And you're asking, I guess, about city JSON in this case, or in general.
Yeah.
So in that sense, you would assign an attribute to, let's say, to the building that the living function of this building is living, or whatever it makes sense for what you want to achieve. I'm not sure if that's answering your question.
I think the functionality of the object is important, but just like you say you have a window.
Yeah, yes, I agree.
The function of the window is to see or to have light, that's it.
Yes. And that
Don't
can be,
model that.
yeah, it can be part of the data set. There's no reason why not. If you will say the data creator, you decide that I want to model the function, then you have the possibility to do so. Yes.
Okay. I think it's essential for the connotation to understand the object.
I agree. Yes.
Okay, thank you. Any other question?
I have a question, like if you want to combine Bing and your city model, that your city model had to be in the level of detail 4, and then they can be combined. If it's just one, how can you?
That's a question I'm going to pass on to the later discussion towards the experts who are in the group. I'm sorry, because me personally, I'm not familiar with Bing at all.
Yeah, well, maybe I could try to begin the answer, but of course we can discuss it later. Well, if we need an LD4, which is actually not so usual in the 3D city models which are now available, but we have, for example, an LD4 coming from BIM. We should choose if we need an LD1 for our analysis, so we can take the LD4 and generalize it to LD1 or LD2 or whatever is needed. Or otherwise, if we really need this kind of geometry and semantics to be kept completely, we should also, well, first of all, understand what is around and if it can be integrated in a similar data set, or we have to model further the 3D city model to achieve an LD4. And we can assess based on the application, the specific application, if it's useful to have the LD4 into an LD1. That can be because we can we can evaluate the performance of the windows and of the door in a different way than for the walls, or considering altogether for having the amount of noise, for example, which is at the inside, and having something around which is not so detailed, but anyway helpful for that. So, but of course it depends on the application and on the specific case, and the discussion is open. Okay, do we have more questions about this, or we will have more space later anyway? So, if that's it, I leave you these presents, this Sinterklaas,
Thank
the
you.
presenters. You're welcome. These are Sinterklaas letters, so ask some Dutch people to explain you who is Sinterklaas and how it works. And I think that in a couple of minutes there will be the coffee break outside. And see you later. Maybe I will take that.
I think the issue also is within the distribution also change. Yeah, that's the main. It's like, yes, we're starting over.
Only 35%.
What kind of charge do you like?
I thought we were Oh, you figured
Check. I wanted to take.
Did you switch off on the microphone already? Okay, so if we take a seat again and everyone will come, we can begin again the new session. Yeah. Okay, so now we are beginning our next presentation that Stelios will do. And as I told you before, we don't have the full analysis yet of the last 3 results, but we still have some patterns and the main issues were already there. So now I leave the stage to Stelios, who will present us the initial things. Thank you.
Hello, everyone. So I'm Stelios Vitalis. I'm also from the 3D Information Group. Francesca asked me to present the early remarks that we have. Yeah. Hello, everyone. Yeah. Okay. My name is Stelios Vitalis. I'm also from the 3D Information Group with Francesca, Barlas, and Tom that we saw before. And I've been asked by Francesca to present the early remarks of the GeoBIM benchmark regarding the task 3, which is measuring the support of CityGML in software. I will go a bit to the, not really the technical details, but what is our perception of CityGML. So first, I would like to start with a question: how many of you have worked with CityGML files? Good. Okay. Pretty good. I guess half of you. The others are from the big world, I guess. From now on, when I talk about CityGML, you saw before the CityGML both refers to the data model and the data format. I mainly talk about the data format unless explicitly told otherwise. So we are a new group. We have been formed in 2015, more or less 5 years. I've been in the group 3 years myself. And we work a lot with CityGML. The title is not clear. We work a lot with CityGML. We work both as developers by developing software, Azure that you saw before, 3D5 or 3D, all the things Barlas told you about. And we also work as users because we conduct research. So this brief look that you can see from the list of publications that we have in the website, in our website, that CityGML is only the title. I measured 25 in the last 5 years. Of course, we do much more than that because it's not only when CityGML is in the title. And also, some of the members of the group have been working with that before even the group was formed. And so, as I said, we have two hats basically, the user's hat and the developer's hat. And we have noticed when we're using as users, that's the hat, that there's a lack of software. It's really difficult when you are given a CityGML file to find the software that will give you a full understanding of the data structure of the file itself. And it's more or less hit or miss. And the second thing that we realized is CityGML are really inconsistent. They're kind of diverse in a bad way, though. So the idea is that we want diversity, but we want diversity of content, of information and data. We don't want diversity of how to explain simple, basic concepts. And that's the case with CityGML, unfortunately, that we see that the same basic concepts, really basic features of the CityGML data model, they can be described in so many different ways that it's really difficult to keep up. So when you're given a new CityGML file, not only you don't know what is inside, but you're also kind of questioning what kind of representation you're going to come against. When we take that hat off and then we put the developer's hat, we pretty much enhance the idea that files are inconsistent. They're also unpredictable. It's really difficult as we develop software. Every time we get a new CityGML file, we are not sure what new generate case and what new creative way of representing the same things we're going to find out. And I'm putting city in parentheses because personally I would blame this more to GML than CityGML. For that. If you have worked with GML files, you probably know it's pretty much suffering from the same issues. And the second thing is that GML and XML in general is kind of hard to handle with most modern languages. So C++, Python, R, whatever you might be using. The problem is GML in paper sounds very nice when you design UML diagrams. When you think about it in conceptual level, it's quite nice. When you're trying to map it to simple data structure like arrays, dictionaries, hash maps, whatever you might call them, if you do any kind of programming, it's not trivial. And some things are so out of the context of how data are really represented in a computer that it's, you have to be creative about how to map it. So Ballas said before we use this GIF every time. I hope I made you proud, Ballas. So not only we thought of that, we also see that the community agrees. So this is one user on the left. You saw that Ballas mentioned it already. But this is a very interesting blog post. I think Ballas also kind of implied it. It's from Ivan Huo. He's the developer of GDAL. It's pretty much the steam engine of all GIS software that you know, at least the open source one, because it provides support for reading and writing all the well-known GIS formats. Save files, GMLs, whatever maybe. And in 2014, while he was writing the GML driver, which today provides the power for parsing and writing GML files to any GIS software, at least open source. And he wrote this blog post where he was describing the madness of how creative and ambiguous GML is by listing all the 20-something, I think you said before 23, different ways for representing one single rectangle of 4 vertices. So if there's 23 different ways of doing so for a simple case as a 2D 4 vertices polygon, I leave you with the imagination of how would that be if there were holes, if there were 3D shapes, and much more complex structures to be represented. So, yeah, that happened, and we were like, okay, we have this idea. We perceive it like that. People from the community seem to like that. Let's measure that. And there's the GeoBIM benchmark. And the third task, which is about measuring the support of CityGML in software, which is mainly conducted by Francesca and a lot of other people are involved into that. So we prepared 3 data sets, one from Rotterdam, one data set of buildings procedurally made, and one data set of Amsterdam. We wanted to have a variety of features to test. So the Rotterdam data set, pretty average, 35 megabyte size, pretty much what you expect to be the typical size of the file that you see from organization sharing when they split a 3D city model into tiles. I would say this is pretty much average to small size of a typical neighborhood or whatever. Both created by the municipality of Rotterdam. The interesting point is that it's a multi-LOD data set, which could pose some challenge when software are trying to parse it. And it has hierarchies like parent-child relationships and things like that. The second data set is one created by a script that Filip Bilecki, a former group member, has developed. And it's an LOD3 data set, so you expect more details, you expect more complex geometries, polygons with holes, windows, doors, things like that. Roughly 1.5 megabytes, a pretty small data set, but we expect it to, of course, challenge the geometric parsing of software and see how they do with that. The third one, it's pretty huge. It's 5 gigabytes, LOD1, created with 3D Fire. It's the whole area of Amsterdam. I think there's somewhere here, something like that. And it's 5 gigabytes. Many object classes. Before we only had buildings. In this case, there's also roads, vegetation, water surfaces, things like that. And of course, we wanted to see how software will deal with the big size of the dataset. And what we wanted to test is pretty much this. Import, of course. Are they going to actually manage to import the data? Is the referencing there? Are semantics and geometry preserved? And is the model managed as it should be? And of course, if in some cases it's not a simple viewer, if there is export functionality, how well they did with exporting the file back to a new CityGML file. And people already submitted 23 answers. I'm one of them. 11 different applications were tested, 14 variations. I think we have 2 versions of FME and 3 different parsers for QGIS, more or less, 3 different versions of parsing GML. ArcGIS and ArcGIS Pro was tested. FZK Viewer, if you know, it's a Windows-only CityGML viewer. 3D CityDB, which is specifically designed in the CityGML model, and it's about exporting the CityGML file to Postgres databases. Azul, which is a Mac OS viewer for CityGML files that is being developed by our group. One Spatial Helix suite of tools for manipulating 3D data, GIS data. EveBeam from the Beam world, not an expert on that, so I guess it's Beam. Nova Factory and 3D Core, both 3D, advanced 3D viewers as perceived by us. So what we know so far, today you're only going to hear some early remarks that we got from aggregating the results. The common things that we found between the different software is none of the software was able to reproduce the same city model as they parsed, period. Unfortunately, there are iterations, either city objects being missing or split to different ones. We're going to go a bit more into details after that. The second thing is type performance seems to be insignificant. It's more of a binary problem. Either it works and it works fine, or it doesn't work at all. We never occurred the case where we managed to import a file, but yeah, it was slow and sluggish or something like that. Most of the time, as soon as you manage to successfully import a file in the software, it's okay. You can pan, you can zoom, you can do all the basic things that you expect in visualization perspective, and any other features that the software might offer. The third one, which is kind of a funny one, is like you see how different data sets completely alter a software's behavior. So it could be that a software, and we're going to list that later, is working perfectly with one data set and doesn't work completely with another one. That's also an interesting remark. Concerning the common features of the output data, we figured out more or less that schema management is okay. Most of the schemas were valid, only minor issues. Occasionally losses of information, as I said before, or alterations, but normally pretty much okay. Geometry always has issues. More validation errors were introduced to the model and things like that, or the type of geometries were not persisted during the transformation and things like that. So, champions and losers, let's say. FME and 3D CDDB seem to have the best support for all the data sets. So I would call both ETL tools, transformation data tools. 3D CDDB is really tailored on top of CityGML, so we expect it to be fine. FME was sort of like a surprise, but we've seen already that a lot of students are working with it, a lot of researchers are working with FME, not such a big surprise. Unfortunately, it seems that GIS software is lacking. So both ArcGIS and QGIS, mostly QGIS, didn't do very well. ArcGIS was okay, but there were some issues when transforming the data to its own data model. Regarding the specific functionality, some remarks. Seems to be the case that GIS, as I said, has the more issues when importing. I guess this is mainly because we had a similar challenge when we were implementing the CityJSON plugin for QGIS. The data model of a GIS is pretty simplistic. It's a tabular form, a relational database, compared to the whole hierarchy complex data model of CityGML. And so many times information were being lost, relationships were being lost. In best cases, there was a parent-child relationship that was maintained through IDs, not the ideal scenario. And there is low support for multi-LOD when importing data. The interesting thing about Amsterdam, we expected it to be a challenge. It was indeed a challenge. Few submissions came back of output of the Amsterdam dataset. And indeed, ArcGIS, ArcGIS Pro, Criticom, eBIM, and Helix failed when trying to open the dataset. Regarding the analysis, I guess that's also interesting in the GIS field. Only FME actually offers a wide variety of 3D analysis to be conducted. Helix and Nova Factory had some specific functions that you could apply, visibility analysis and buffers for Helix, and for Nova Factory, visibility analysis, shadow analysis, sound analysis, and extracting height profiles. Editing here is where GIS shines. So as soon as you import whatever you manage to import, at least you are able to edit it one by one manually, the geometry, or at least to a certain extent, mostly 2D, both semantics and geometry. Other advanced 3D viewers, eBIM and Nova Factory only supported semantics editing, not really geometry editing. FME, again, has the most functionality, but FME, you expect it to work in batch, like with multiple objects and using transformation for that. I guess you could always write your own ways of isolating one object and changing it, but it wouldn't be as trivial as moving one vertex here and there. And now for some individual remarks on software, 3D CDDB seems to be the most consistent one. It alters the input the least. Only one file was broken, and that was due to just for a bad X-link that was introduced. And there was a slight reduction of objects in the Amsterdam dataset, not sure why. Seems to be quite robust though. FME also the same, quite robust, more changes, but still generally okay. You would expect that the output would be okay. Okay. Yeah, and there was some interesting cases where by using some functions, we would lose the bridges in the Amsterdam dataset. Some remark that we found out. QGIS, yeah, didn't do that well. Only one file was submitted back, and it was empty and invalid. GML and QGIS doesn't play well, I guess. But actually, there's a new driver that Van Gogh has developed a couple of years ago. I'm not sure if QGIS takes advantage of that. Not my position to say now. ArcGIS managed to parse the geometries quite well, but the problem is that every semantic surface was converted to an individual city object. And then the city objects themselves kind of got lost. Therefore, we had a huge increase of objects because now instead of having one building, you had one individual surface, like a wall surface or a roof surface, represented as its own object. And there was a tiny issue with the schema validation regarding some dates. That's the only schema validation issue. And Nova Factory, that's, I think, the best example of this binary behavior that I said before. Rotterdam was almost perfect, the output. It was valid and everything. Of course, some alterations here and there again, but for Rotterdam it worked very well. For Amsterdam it didn't work at all. So that leads me to the discussion. So GIS doesn't seem to fit with CityGML very well. I feel a bit bad about that, being a developer in the GIS world. It seems that ETL and specifically tailored software for CityGML seems to be the best case for working with it. And actually, I think that might match what OGC is trying now to promote for CityGML, as lately I've seen that they promote it more as an integration format than a GIS format. Maybe that's the case after all. And it seems that schema is not as much an issue as geometry. Of course, there is an issue, there are still alterations, there are still just here and there, but at least we have valid schemas most of the times. But we get a lot of the geometry errors, and that's something to be noted. And what can we learn from all of that? Well, the first thing, that's more or less my perception, a standard can be a standard without really standardizing it. And that's the case with GML. I mean, it's a standard, but every time you get a GML file, it's like, oh, what new way is there to represent the same things that I knew before? And as a developer, you probably know how hard that is. You expect to have a specification upon which you can build your software, and you expect that at least you only have very few percentage of degenerate cases. That's not the cases with GML. The second one is stay away from XML. I think I explained that already, but it seems like the world is moving away from these conceptually very nice, but software-wise really difficult to have to work with data format, unless you're working with Java. That's your concern. The third one is that complicated hierarchies come with a price. So all these nice things with city objects, semantic surfaces, and things like that, we need them, of course, but we should expect that they add complexity, which really is challenging when we are developing software against that. Because most of the data structure, as I said before, they are really simplistic and flat. And we should expect there will be issues when transforming from one data format to another. And the fourth one, again, kind of like my personal view on that. It's always better if we favor constraints over ambiguity. I would phrase it better if like, we have constraints over freedom when you're going to add ambiguity. And that's, I think, the case. It's better if we have to sometimes go around and represent our data in a more strict way, even though that might be difficult sometimes, non-trivial. But at least then we know that because we have a simple structures of data, we can always parse them and analyze them and work with them. And based on what we've learned from all this, I think Balas already told you about CityJSON. We developed CityJSON and we try to solve most of the issues. First of all, by skipping GML and XML. And second of all, mostly by trying to follow the last point. It's like we flattened the model, we chose to have strict ways of doing stuff just for the sake of making our life easier as software developers. Not, of course, against data users, but I think in favor of data users. So if you have issues with working with CityGML, here are my suggestions of 2 steps for success. Take the CityGML, convert it to CityJSON, and enjoy. There's much more software today for that, or at least you can use both, right? If it works with CityGML, you're fine, don't do it. But if it doesn't, compared to CityJSON, there are a lot of tools to work with, and I think it's much more about it. So, one last thing. I've been asked by Francesca to show you 3 of the software projects that I'm personally involved and might be interesting for you, GeoBIM users. The first one, most of them, I think all of them actually were kind of mentioned by Ballas. The first one is the QGIS plugin. So you can install it through QGIS. It's in the list of available plugins. And you can load CityJSON. We also have very nice metadata viewer. That's one of the powerful points of CityJSON. It has metadata support. And you can load your data. It's been available for a year now, more than a year actually. And it's been used both by us and by people outside from some organization in Switzerland, Jordan. I see celebrating. And we've been told it's nice. Thanks. And we're now working in integrating it with a QGIS toolbox. So the idea is we are adding now functionality of CGIO to QGIS toolbox so you can do validation, subsettings, and things like that. And that's a work in progress, but we hope we can have it soon. So a nice way to navigate through your data. The second one is pretty much the output of a master's thesis that is being conducted right now from a student, Konstantinos Morakis. He's working with the municipality of Rotterdam. And it's also related to what I'm going to present tomorrow, the concept of versioning in 3D models, but we also wanted to provide a tool for stakeholders, practitioners, mostly architects, to be able to actually open a file in the 3D modeling tool, such as Blender, edit it, manipulate it, and then export it back. So now the import functionality is there. It seems to work. It's quite robust. You can find it here in GitHub and download it and install it in Blender. As I said, for now it's only import. Currently the student is working with the export functionality. I guess in a few weeks we will have that. And the idea is, as I said, either to use it to edit manually the geometries of 3D model, or to use it as an ETL tool for BIM, because Blender also has an IFC plugin as far as I'm concerned. I'm not sure how well it plays with all the IFC data, but in theory you could be able to export and import IFC models to a 3D model. And the last one is Ninja. So Ninja is started like a pet project. The name itself is kind of an inside joke I'm not going to explain now. You can play with it here. It's like the web viewer that Dala said before, but we're trying to enhance the UI. And the idea is that we want to offer a better understanding of the structure of the file. Later on, as I said, tomorrow I'm going to talk about versioning. We are planning to incorporate versioning here as well. And we also offer some basic editing capabilities, mostly for semantics. But the idea is it's web. It's just basically. Sorry? Okay. So, yeah, the idea is you drag and drop your file, you check what it is, you can see the hierarchy, you can see what kind of LODs you have, and if you click in an object, you can see better the attribute and the type of geometries. Things that you think are trivial, you expect to find some other way to do so. But personally, I've never felt that there's tool specifically for that. And you can go and this link, CityJSON.github.io/ninja, and play with it. And that's it. Thank you very much.
Thank you, Stelios. So, sorry, I leave you take the pictures. And do you have questions? Now we have some 15 minutes to discuss and to give you more details on all these presentations of this morning. So if you have any questions, please ask. Yeah.
Question. You were talking about CityGML converted to CityJSON, but is the problem with CityGML mostly in the fact that it's XML or in the structure? XML can be really flexible. That's the problem, right? That you can predict where certain data is, right?
Yes. So
JSON, you can do exactly the same with JSON. So are you just converting it from XML to JSON, or are you also changing the structure of the data?
yeah. Well, first of all, as Bala said before, the conversion tool is not done by us. I'm going to go a bit into detail later on, but we have a specification for CityJSON which pretty much replicates what the GML does. But of course, JSON and GML are completely different because GML can be so creative and abstract sometimes. So yes, we took some decisions that kind of restrict the model. But if you take the CityGML data model, we can represent it in more or less 99%, let's say, of the features. But some things are more simple. Like one simple scenario is in XML, you can have an object inside another object. In our case, we just chose to have this flattened. Of course, you can do that in JSON anyways, but we chose to make it flat because we think it's better sometimes.
Because you could also do, I think the same with XML, but it's mostly JSON is easy to work with the programming language, right?
Yes, that's also
You
the.
can also restructure the same thing in XML, right?
Yeah, my personal experience and also what I share with all the other people in the group, that they work with different languages. We work with Python, C++, things like that. The only thing we're not working is Java, and it seems to be the only one that plays well with XML. Most of the tools of Java development, they are using XML configuration and stuff. C# a bit, but still. Yeah, every time we had to deal with CityGML before we invented CityJSON and we wanted to do research and things like that, we had to do ad hoc solutions. So try to extract the information that we didn't need and develop a piece of software that works specifically for what we wanted. And a simple example is in the Azure. In Azure, Ken is the developer of Azure, the main developer of Azure. And what he does effectively is he emits any other kind of information, only goes through the geometries. As soon as he finds a geometry, then passes it, and that's it. Because otherwise, trying to map this whole complicated structure in memory is really complicated.
Thank you. Yeah, go ahead.
Thanks for the very interesting talk. I think it's a follow-on question to this one, really. You mentioned that the majority of the problems related to geometry rather than just semantics.
More or less, yes.
So with CityJSON, have you done anything specific with the geometry model that simplifies it?
I would say that's the thing where we mostly altered the situation. We have a very specific way of describing it, and we tried actually to take the successful model of representation from the OBJ files. You probably know OBJ files. It's a really basic 3D geometry format. And we try to replicate that because it's like it's there, it's robust. We've seen so many 3D tools that work with that. And that's what we basically implemented in CityJSON.
Has there been any loss there by doing that?
No, as far as I'm concerned, no. No, actually, the 25 type, it's not really different types of the geometry. That's the madness of it. It's 25 different ways of representing coordinates inside, outside, that way, the other way, with CRS, without CRS.
So it's just constrained.
Yes. You're welcome.
Thank you. Other questions? Okay. So if there are no other questions for the moment, if we have in the meantime, you can just keep them in mind, and maybe in the later session today we will discuss them more. And so this was the thank you, Status, for your presentation. And we can finish this morning part. I would ask you to move and have a walk downstairs where we can take a picture of together. And after that, we can come back and have lunch. So enjoy a little bit of fresh weather. Okay. I hope you enjoyed your lunch, and we can start the afternoon session with BIM. Now I leave the stage to Lorenzo Polia, who is an architect and practitioner, so it's really work for us to have such a collaboration, and he will explain you what BIM is and more details about it. Thank you, Lorenzo.
Good morning to everyone. I'm Lorenzo, and I want to introduce you the topic of BIM. Before focusing on this argument, it's better to understand the problems that bring us to develop this new methodology. So let's see the typical problems in construction industry. We have these 5 points. The first one, the 30% of the project does not meet the original budget or the original program. The 92% of the clients say that the drawing produced for the construction are not enough. The 37% of the material become waste during the construction process. The 10% of cost will increase during construction, and the 38% of the carbon emission come from the building and not from the cars. So, what are the causes of these problems? The NID University produced this survey based on 10 points. The BIM can solve some of these problems, but let's see it. Only these 4 problems can be solved with this new methodology. So we have an inefficient project management or inefficient cost control, a conventional method of cost estimation, an excessive change order during the process, and an inadequate project planning. Maybe the BIM can solve this problem. Examine the evolution of the design process. At the first step, we have the end drafting. Obviously, the designer had to physically draw their ideas to communicate their vision to the clients, to the stakeholder. This method produced a lot of error. In fact, the most of the time was used to change the project, to change these images, to improve the project. At the second step, we have the CAD. It is a computer-based technology. CAD means computer-aided design. CAD software are able to produce complex 2D drawings and also some basic 3D models. At the third step, we have the BIM, the BIM, that is a 3D, three-dimensional design process based on parametric objects. This means that all the components or the object inside this 3D model can be managed by some parameters. Let's analyze also the history of the building information modeling. Okay, the first conceptual idea is by Douglas Engelbart. Douglas Engelbart in 1962 published a paper called Argumenting Human Intellect, in which he talks about his vision about the future of architecture and also inserts some strange idea, some concept that can remind the philosophy of BIM, the BIM philosophy. The first working prototype of BIM is by Charles Eastman in 1975 in his thesis. He analyzed and described for the first time a new building description system, where several concepts of BIM were mentioned. Then we have the first use of the term building modeling in the real sense of BIM by Robert Esch in 1986. And the first, 1 year later, we have the first launch of a successful BIM software. Several times we have some software that try to integrate BIM function, but the first successful one was Radar CH that will become ArchiCAD, one of the most diffused software in the world. Only in 2000 we have the first development of Revit, that is the most famous and used software in the world, that will be acquired by Autodesk in 2002. So let's define the BIM. This is the BIM definition by the American Institute of Architects that define the BIM as a model-based technology linked with a database of projects. This is a perfect definition. In fact, we can explain this with the tip of the BIM iceberg. What is seen is the 3D visualization, the 3D model, and some basic quantities. But inside the model, we have a lot of information. We have a database that can include thermal analysis, structural analysis, prefabrication, management plans, etc., etc. Also, the BIM can cover all the life cycle of the building. We can see by this graph that only the 2% of the time of the building life cycle is spent in design. The 34% of the time is spent in construction, and more than the half, equals to the 64%, is spent in operation and management. So the BIM can save the owner time and money because cover all the building life cycle. If we try to make a comparison between the BIM and the CAD, we can see some differences. Let's see the first graph of the 2D CAD workflow. The most of the time are employed to produce documentation, and to coordinate the stakeholder inside the process. With the BIM approach, the most of the time is used to design because the software can produce easily the documentation and also has a lot of functions that permits an easy coordination between the actors involved. So we can spend the most of the time in the design. This obviously brings the design to the next step and produce a better quality of the project. You can say that the BIM is also a new philosophy. The way of drawing has changed with CAD, but the way of design will change with BIM. What does it mean? Okay, let's see some different approach, like in the communication and in data exchange. In the first peak, we have all the stakeholders involved in the traditional design process. We have the architect, the structural engineer, the lighting designer, the building owner, the facility manager. Okay, this actor involved produce the documentation and the exchange of data, the exchange of information is chaotic. With the BIM approach, we have a central shared project model that is accessible to all the stakeholders, to all the actors involved, and contribute to velocize the process. This shared project model is placed into a shared digital space that is called common data environment, and all the actors can load and update the data, the information inside this space, this digital space. This digital information could include also specifications, schedule, performances, analysis, drawing, every kind of documentation. What is the federated model? The federated model is a model that contains all the model making up the entire building. In this case, this federated model contains 3 different models from 3 different disciplines. That is the architectural one, the structural one, and the map. The map is an acronym that indicates mechanical, electrical, plumbing, the system design inside the building. To create the federated model, it's necessary that the 3D model can communicate each other with an interchange format. To remedy this problem, Building Smart International was founded in 1995 and introduced a new standard that is the IFC format. IFC is another acronym that means Industry Foundation Classes. And we can use the IFC format to exchange and share BIM data without the software having to support multiple native formats of every software developer. Let's see some application and advantages. We have a unique management of project view. This means that every modification is automatically reported and uploaded to each view of the project. We can change some parameters of an element that is placed inside the model, and every view is updated with the new changes. This obviously means that this leads an important a significant time saving and a significant reduction of errors. The BIM software also permits a sample visualization of the project. We don't need it to be an expert BIM user or a BIM software owners, but we can visualize the project, the 3D model, with some cloud services, some smartphone application, BIM viewers, all
or also the virtual reality. We have a high level of customization. Every BIM software has parametric components that permits to change quickly the value of the parameter. Like in this example, we have a door that has some material and finishes parameters and some dimension parameters with the height and the width. We can change this value, and all these components inside the model can change altogether. This parametric object has a level of development. We can split this level of development in two parts, the LOI and the load. The LOI is the level of information, the quantities of information of data inside the object, and the load is the level of detail, the level of geometrical detail that we apply to the 3D model. As I said before, we can use the BIM model also to produce the project phasing simulation. This because it's possible to assign a time parameter to all the components within the model. It's possible to view the evolution of the construction site during the construction process from the foundation up to the roof, as you can see in the image. It's possible also to make an estimation of this of the model. Every BIM software has some schedule function that permits to extract the quantities of every object into the model. We can also assign a cost parameter to the elements and processes to obtain a total cost of the building, of the works, of some parts of the model. We can use it also to produce an energy model. We can do some physical analysis of the building, like the life cycle energy performance, the sun and shadow study, airflow analysis, etc., etc. We can use it to produce a facility management model. All the database that is included in the 3D model can be used to create a maintenance plan. And we can use it to do the interference check. In this case, BIM software allows to check the interferences between the single component inside the model. We can see by this peak there is an interference between a structural beam and a pipe. Okay, we can launch the clash detection that identify the interference in the model that we can then solve it manually. The BIM software also allows to the production of many views that enhance the project, like the renders, animation, and sketches. But at the end, we can say that the BIM can be used to do the repetitive work by the machine. Is a quick instrument that draws more precisely and can also be used by faster project delivery. These are some BIM software. The most famous one maybe is Revit, followed by Archicad. Oops. Okay. We are then. We have also some structural BIM software like Tekla and Shia. We have also computational design software like Dynamo and some software that are used to the interference check like Naviswork and Solibri. This is the adoption of the BIM method around the globe. You can see that in the US, we have the most of the adoption, 70%, followed by Australia, then Europe, Middle East, and India. This is my last statement of Albert Einstein. I never think of the future, it comes soon enough. This is me with my contacts. Thank you.
So thank you, Lorenzo. Interesting presentation. And do you have any questions? Okay, we will have a question and answer session later on purpose. You deserved your letter of sympathy class.
Thank you very much.
Okay, come on the stage. Yeah, we can pass to the following presentation from by Edna. Yeah. So I like very much the image of the iceberg, both in the 3D city model presentation and in the BIM presentation. And is it working? No. Good. Right. Where did you do the screen? I'll move it. I'll have it move it. No, wait. Then I don't yeah, I don't know. Okay. Is it okay like this? Yeah. Okay. Next time, good sorry. Okay.
So
Sorry for
I will
technical
have to
problems.
randomly turn away from you to look at the screen because I can't see which slide I'm at. But welcome. Another disappointment apart from looking away from you sometimes is that I think I will kind of disappoint people who wish for 3D realistic views of things, which I learned today are most of the people. And I think there's not a single 3D image in this talk, but this maybe works. So I will talk about the standards, also with some technical detail, more technical detail, assuming that there's less knowledge about the building information modeling standards in this room. But I may be wrong, so let me double check who has worked with the IFC before. Yes, quite a lot. But still, I think it makes sense. Yeah, I want to go back a little bit longer in history because these preliminaries of IFC still referred to today. They explain some of the oddities which we deal with when we look at IFC in particular these days. So the standard for the exchange of product model data replaced previous format IGES in the product model domain in 1984. That must have been somewhere between, or yeah, that was even before the term building modeling was coined in 86. And then 94, 95, that standard became ISO accepted, and it is a larger series of standards actually, where I picked some sub-series which are important, which is the 10, the 11 and following series about the conceptual modeling, where, yes, if we speak about the model and the shared model, it is not necessarily about a shared data repository, which is a single source of truth. I think there was quite some time when people thought that that would be possible, but it turned out it's not. But even if we accept some distributed data resource, then the main thing is that we have a model where we share the conceptual model. So we speak about the same things. And if you ask what is a model, then one of the standard answers is it is an image of something that is simplified for a specific purpose. So there is no model without a purpose. And if you don't really have a purpose, then usually people go with visualizations or something that is, that they can look at. Then that's the part that supports the conceptual modeling for product models is the 1x part. Then we have the part that supports implementation methods, starting with 21, which is more or less what in the geo domain is called encodings, I would say. And then we have a series of, in the 40s, a series of parts which deal with geometric representations. And finally, in the 200s, there's application protocols, which are different, various specializations of the standard for different domains and different applications. And in the early years, there was also draft for building and construction related application protocols instead. We will later see that was replaced. I've picked from three of this series the three main things which I want to look at in detail. Three main parts. The first one is the part 11, the Express Language Reference Manual, which provides a way to describe the data model. From the 20 series, there's the step physical file, one of the most used implementation methods, aka encodings. And finally, the 42 is one of the parts about geometry and topology. So, yes, first one, Express Language Reference Manual. So this is a way to describe the data model. If we look at the information modeling, which you know is not data modeling, but if we look at information modeling from kind of a linguistic point of view, then we have a syntax, so we have a terminology and a grammar, and that together makes up our data model. But that's not enough, of course. For an information model, we need meaning to the data, and that means semantics, and it's a little bit different use of semantics also, but from a linguistic point of view, which means in addition to the data model, to come to information modeling, we need semantics. But this part deals with just the data modeling and provides ways to describe data type definitions, structural constraints, algorithmic rules, and it has a graphical version, Express-G, with a very small number of symbols for entities, for enumerated data types. defined data types, and so the most used are the entity data types. Enumerated data types are choices of strings. Defined data types are subtypes of the simple data types, and select data types are choices of other arbitrary data types. So quite complex. Then we have which is called attribute symbols, where you describe, while with this you describe the the concepts that you want to model. With this you describe how they are related to each other, and there's a mandatory and an optional relation between two entities, and we also have specialization relation. I want to draw your attention to that this relation points towards the subtype, so it points towards the specialization, whereas in UML or nowadays more common data modeling languages, it points to the generalization. We have this triangle on the upper part. So these are the elements that we have, and if we want to create kind of a very simple custom BIM which only knows columns and walls and some parameters, then it could look like that. We have some subtyping relation here. Columns and walls both are construction elements and also share these parameters, and then they are in stories, and the stories have an optional attribute name. So this as an example. There's also the textual version of Express, which is a machine-readable version of the graphical structure we just saw. So in this textual version, we have all our entities described in one schema. Schema has a name, and then the entities get their attributes, and also the subtyping relations are defined. Yes. Then, so far, we've only seen simple cardinalities. So, but there's also a way to handle aggregations of entities, and Express defines 4 different ways to specify aggregations, and these are set, back, list, and array, where the set and the list are the most commonly used ones. There's no backs in IFC, so the difference between backs and sets is that it allows for duplicates the back, whereas sets don't. There's also versions of the list and the array which don't allow for duplicates, but they don't have a separate type. So you can have a uniqueness constraint, and then you have kind of almost all of the 8 possible combinations, except 2 that don't make sense. And then using these aggregation types, they are also used to specify cardinality. But let's first look at cardinality ranges separately. So simple attributes have a cardinality of 1, minimum 1, maximum 1. Optional attributes can have 0 or 1. And for these, we have seen the solid and the dashed line. In Express G, for all other cardinalities, higher cardinalities, they are specified in angled brackets with the minimum and the maximum separated by a colon. And then the aggregation type together with the cardinality is specified, it can be specified in the graphical version of Express as well as in the textual version. This is now an example from this simple custom building information model we've seen earlier. So the relation between a construction element and a story. If we would model it the other way around, from the story to the construction element, then we would have more than one element in the story, and maybe we want to put the constraint that the story cannot exist without at least one construction element. They don't need to be ordered, so it's a set, and then this will be the cardinality. In Express, all the relations have one main direction, which is always the main, and the inverse is always implicitly there. There are some reasons why you may want to explicitly specify the inverse, as it's done here. So we still have the main direction simple attribute from construction element to story. And these two reasons are if you want to name the inverse, so you want to address it with some name, then you explicitly specify the inverse. Or if you want to define cardinality, bidirectional cardinality, as in this case. Yes, another Express concept is rules. So this is an example of a domain rule for our custom simple building information model, which says a wall should always be somehow flat, and we define flat that one of the dimensions, the depth, is at most 20% of the length and of the height. Yeah, that's wrong. There must be so there must be depth smaller than 5 times the height. But that's an example for a domain rule which constrains the domain of the type wall. So now, not everything can be a wall. Only those that conform to this constraint. There's also global rules in Express, and of course rules are used for full functions. There's also the possibilities to define functions. They are declared in the schema and then called in expressions, and they are used, for example, in rules or in derived types. So the next of those parts, so that was the Express language. The next of those parts is the step physical file. That's the clear text encoding of the exchange structure. I would say the most compact, it's optimized for compactness. So it's very small, and I think the ratio of step to IC XML is much smaller than 1 to 7. But yeah, it's an ASCII data format, human readable, and also machine readable, of course, and similar. So that's just a header and with some metadata with the file schema, the most important one for now. And then here's the data section, and the data section is kind of similar to the city.json. It's a flat structure which just lists the entities separated by semicolon, and they are every entity has a file-wide ID, this number, so, or document-wide. I just and I'm not sure. It's too long. Okay. Just something without.
I will ask for a new line.
Yeah, but I'm doing.
I'm trying to open on it.
Yeah,
Yeah,
but
that's
I'm
always
doing-
good.
It's not working. Never know. Unless it takes hours. Yeah.
I can hold the laptop with you.
It's actually using on the laptop because it seems to be that cable.
Yeah, this one.
So we have an alternative solution, we have a backup solution. Yeah? Yeah.
No, it's up. You want to try to turn it on again? Or not?
Yeah, it's also possible. So
I
then
tried it. Just try it.
It's too hot and then. Can be after a few hours. We should let that one.
It doesn't have to be
So connecting to that one is fine.
What is it? Oh, okay.
Or do you have it on the flash drive?
You wanna, okay.
You can connect yours.
I can, yeah, I can also. Okay. I can also copy it to a flash drive, of course. But this one also doesn't work. Okay, so.
Is it working?
Right now,
Should we change it? Yeah, but maybe it works for a while, we could change it anyway. No? Yeah, but it's not working with mine and with yours. Yeah, but it works for a while and then It's better not to do it.
it's short and simple. So maybe one.
Ja, dan wordt het juridisch.
Ja, wel zeker.
It doesn't change. Okay. No, because
Sorry for the technical issues. I hope that now it will work better.
So now I go much quicker because my time's already over. I said it out, but maybe you digested some of the things, and then we have the header, the metadata, and then the list of flat list of entities. Now I can go back. Where yes, the attribute values are just written there in order without any notion of which attribute is which. So they so this of course only works if there's some order, reliable order, and it is defined that this is the order, the same order as the attributes are defined in the express file, with the ones that are from the most general types first, and the one from the most specialized types last. Otherwise, that's the order of definition. So, for example, for our example, we remember that we had the relation between the construction element to the story defined in the construction element, so in the super type, and this is the one that comes first. Also for the column, and also the height is the same height everywhere, was defined, and then the last, the next two attributes are defined on the specialized level of the wall and the column. And because it relies on this ordering, it just that's the bare minimum to name the type here. Somewhere, of course, you could make numbers from that and obfuscate it a little bit more. But otherwise, because rely on the ordering, it's really the most compact you can get with text-based data formats. One thing I wanted to, or maybe not, no time for that. So the third part I want to look at very briefly is geometry and topology, the 42 part of ISO 10303, not 1 too much. This part of STEP was designed to it defines the different ways of describing the geometric shape of models, and it is mainly about solid models and addresses, this is literally there in 42, the two classic types of solid modeling, which is the constructive solid geometry and the boundary representation. And then, apart from that, there are geometry and topology resources, that is parametric curves and surfaces, and topology mainly used for the boundary representation, that are there to, in the first case, to support these two ways of modeling, which come from the early 3D computer-aided design. But it's also open, so also for the boundary representation, it says these topology resources can be used for other things, and also the parametric curves and surfaces can be used for other things than solid models. So you can have surface models, and while these two models are meant to be proper and valid solid models, the standard explicitly allows to use this lower level resources for incomplete models or models where you cannot guarantee the integrity of these representations. But we saw the rules. They are used, for instance, to pose integrity checks on the boundary representation topology, and are also used for other things. I think there will be maybe more information in the next talk. So now we come to, that was the 3 parts of STEP. Now we come to actually IFC, and IFC started out in 1994-5 as an industry consortium led by Autodesk, called Industry Alliance for Interoperability, and there was a first version, IFC 1, in 96, and that was, if we think back, quite soon after, or almost the same time as the STEP standard was ISO certified. At the same time, the construction industry decided they want to not go with these application protocols in STEP, but they want to do different things, and they also want to throw away some of the baggage. They want to have something that's more adjusted to the construction domain. Then there was a quite quick rename, 97, in International Alliance, to open the have a more open name, which is not only CAD software vendors specific. And then in very quite quick periods, there was a couple of releases until 2005 was the 2x3, which is still in use till today, and also the rename to Building Smart. The last technical corrigendum, so the last update to IFC 2x3 was in 2007. And after that, it took kind of 6 years compared to the quick development before to develop IFC 4 and then have that ISO certified as well. The main implementation method used is also the step file. There's also IFC XML. There's also an OWL implementation, and there is, but the main, because of its compactness, is the part 21 step physical file, which looks exactly like the one we saw before. Then we have some more types than those 4 that I had in the made up example. So for IFC 2x3, we used to have something was called the IFC wallpaper with all the Express G on one large sheet of paper. I don't think that exists for IFC 4. There's also, I think, kind of 100 more entity types. It's in the 800s now. And we also see that there are 2 global rules and a lot of domain rules. Unfortunately, although these rules are very useful in the IFC area, there's not much software that can deal with these rules. That's a little bit larger. So, of course, in such a mess, you need some bit more organization. So it's organized in 3 layers. The bottom layer is the resource layer, which contains basic concepts. For instance, we have here the geometric model resources, also geometric constraint resources, and geometry resources, but also things like date and time and material. Then the next layer is the core layer, which contains domain-independent concepts. The interoperability layer contains concepts that are shared between domains, and then the domain layer contains concepts which are specific to domains like the architecture domain or the structural analysis. And references between these layers are only allowed top-down. That may seem a bit strange if you think about it, because the specialization goes bottom up. But if you remember, so you will have the specializations attribute relations pointing upwards. But if you remember what I said before, actually in our modern, in UML, for instance, it's the other way around, and we point towards the more general types. So another thing that's special about this lower layer is the resource layer. All the elements in the resource layer are not allowed to exist on their own. So they are only helper concepts for everything else. And the entities in the kernel and higher layers are all based on IFC root, which is the base class for all the objects that can stand on their own. And that's also why they have a global ID. So you can recognize them and find the similar one in a different document, even if there's no strong identity to these elements. And the main subtypes are object definition, relationship, and property definition, where the object definition describes semantically relevant things or processes, and this thing is really wide, so it can be also a type object. So you have a type object type, which is here, for instance. And the property definition describes groups of characteristic properties. The relationship, objectified relationships. Here is one example of a relationship subtype which describes the relation between object and its type objects. So there are many more relationships, many more object definitions, and also property definition subtypes. The main one we want to look at is the IFC product, because the IFC product compromises all entities with geometric or spatial context and representation. And it has two important subtypes. One is the spatial element and the other is the element. One is for physical elements and the other is for spatial structures or zones. And then what we often look at is a specific type of physical element, that's a building element, and below that there are all the types that we are interested in, like IFC wall or IFC slab, column, and so on. The spatial structure also has a couple of subtypes, which we come to later. Then the product, the most important thing, because it has spatial context and representation, it has two important attributes, which is the placement and the representation. Both are optional, so you can, of course, have products without geometric representation. And here's one of the more important also relationship subtypes, that is the contained in spatial structure relationships, which describes how a product is contained in a spatial element, for instance, a wall inside a story. This placement, I want to look at the placement and then at the representation briefly. The placement is usually done in three-dimensional Cartesian coordinate systems. That means placement and coordinate systems. And they are referencing each other in so they are relative to each other. For instance, you have one coordinate system for the whole building, then one for each story, which is relative to the building coordinate system, and then maybe for each element to place the openings inside. This is realized. This is how it's realized in the schema. So we have a placement. One type of placement is this local placement, which is relative to another placement and has some placement information. And this placement information has a location, which is, and that's mandatory, which is this point. And then has this is expressed with 1, 2, 3 coordinates, depending on which dimension you're in, and also optional 2 directions if you want to rotate the placement. And then in the concrete instance, this is not defined in Express G, but it's used also in IFC specification, this type of object graph, where you have concrete objects. And it makes it pretty clear that you have a placement which is relative to another placement and relative to another placement. And then here's the placements and the points. And then in looks like this in the step physical file. So you can imagine here, this is your building, this is the side, this is the building, which is offset only in the XY direction, and then you have the story, which is offset in Z direction, as an example. Then concurrent to this placement, oftentimes we have a spatial structure, which is the aggregation structure, which is defined on any object. So you can define aggregation on any object, and it's also done for instance, for systems, for static analysis systems. You can deconstruct any system in this hierarchical order, not only spatial structures. But the most common thing that we see is the spatial aggregation, and this often goes hand in hand with the relative placement. And the last, so that was the placement, and the other thing that is specific about IFC products is that they can have representation. It's an optional attribute, and I just want to mention here that this representation, there can be multiple representations, which consists of a set of items, and each representation is assigned to a representation context. And as you can probably, the representation context defines something like the coordinate space dimension. So you can have representations that are 2D and others that are 3D, but also precision. So you could have different LODs in theory, levels of detail in that case, and world coordinate system and true north. So this is an important element which will reappear tomorrow for the georeferencing part. And another important concept is properties. These properties are predefined sets of additional information that you want to have for specific entities. There are complex and simple properties. The simplest property is property single value, so it has just some name. It's just a key value and the value. And an analogous thing is physical quantities, where you want to have quantities explicitly in the model, which are derived with some defined method from the 3D data, of course. But as there are different conventions how to derive these quantities, which detail to include, whether to subtract the openings or not, it really makes sense to have those in the model as well. And here's just some statistics, how many of these property and quantity sets are there defined in IFC4. So one example is a property set which has the name pset. Pset, these are all the predefined sets, window common, and then a lot of single values for the fire rating, burns 30 minutes before it's destroyed, is external, and so on, thermal transmittance. Yes. And last thing, I want to briefly mention some more building smart standards and make some comments about certification. So apart from industry foundation classes, which we saw right now, there are two more important ISO certified building smart standards, which is the International Framework for Dictionaries, standardizing the naming of and concepts, harmonizing them across different languages, which you can imagine is not an easy undertaking. Then the information delivery manual, this is related to the processes and the data requirements that appear in different processes. So an information delivery manual is an informal specification that describes processes and information flow during the life cycle of a facility, and is usually written down in business process model notation, where you explicitly say this actor needs this data at this point in time in the project, and then these are broken down into separate exchange requirements. And then from these exchange requirements, you can derive model view definitions. And while the IDM was informal, model view definition are formal. Exchange requirements are somehow in between. They usually are tables of data and their domains. Yes, the model view definition is defines a subset of the IFC schema that is needed for a specific piece of the information flow across the whole project, and is defined in XML. And these MVDs have another important purpose. So there are 3 MVDs defined, main MVDs. There are some add-ons and subtypes defined for IFC 2x3 that are grouped along the broad domains, kind of. There's coordination view, which is for coordinating all the parts of the partners of the project, and structural analysis and basic FM handover. In IFC4, this has changed. So now we have a reference view and a sign transfer view. And this is not about which domain these models are for, but it's about the nature of the exchange. So reference view is meant to be exchanged only in one way. And in the receiving part can use it as a references for their own modeling endeavors. And then on the contrary, but it's not meant to be returned, something changed and returned. That's what the sign transfer view is for. The sign transfer view is meant to come back to the CAD system and then with changes. These MVDs are used for certification also. So software that does export and import certifies not that it's capable to import or export the whole schema, but it is certified for conforming to a subset of the schema. And for IFC4, the current certification is, I think, mainly finished for references view. The sign transfer view turned out to be quite hard thing to do. So most of the models that we see for these reasons are reference view models that are not meant to be re-imported back. So this is just how that looks for IFC3. So we have the certification here. You see the MVD, so the subset of IFC, which is certified, and then whether it's for import or export. And there's also then some more detail where it says which concepts are actually implemented and is it properly implemented, the interpretation. And then there's also statements from the companies if they are not implemented to the full extent or not implemented at all, why that doesn't make sense for their specific software because they don't support these concepts. I think that was it. And I don't even have a final slide, so I have to maybe, I don't know, yeah, maybe.
Thank you, Helga. So thank you for the presentation about IFC. Do you have any questions for Helga? Okay, so for the moment it's all. So thank you for your presentation, and we can follow with Thomas that will instead show how IFC is implemented and what are the most common issues and technical sides of IFC. Would you? Okay, you can follow. Okay, and he will also show the initial analysis of the results that we made for the task 1, so support for IFC. So, stage is yours.
Yeah, thank you, Jessica. Thank you, all the presenters. So I'm Thomas Krijnen. What I do now these days is I work as a maintainer of a open source software library for end users and other developers and implementers to work with the IFC file format. I have a small consultancy company around that, and I have a postdoc also in the group where you have seen several people of now. Wonderful group in Delft. So for me, this problem of geometry interoperability and IFC, and now later CityGML perhaps, that's a lifelong quest actually, and whether it was in my research or in my commercial activities. Geometrical interoperability is really a hard and for some people necessary problem to solve. And so I'm very happy with this benchmark initiative to look at these things from a very practical side, see what practitioners are encountering, because it's you can approach this problem from two sides. You can look at the schema and say, gosh, we have nearly 1,000 entities, 20% of them are geometrical. Dear God, that's a huge implementation effort. What can we fundamentally represent? What does the schema allow? Or you can just look at some files in practice, see how they work, what are the problems they are encountering, and I think that this benchmark allows both of these perspectives to influence each other. I wanted to start with something like what do you want to tell your end users about the problems with a certain IFC file or with a file in general? I mean, I think I heard the statement about CityGML that none of the data sets that we looked at were valid or valid enough. I can promise you, if you look hard enough in an IFC file, you will find something invalid there too. And as Helga said, that can be in a syntactical level, or in the value types, or in these cardinalities, or in these where rules, which, as said, practically nobody has implemented. I'll look at that a bit later. But still, and I try to use my best artistic abilities to represent this, and I went to architecture school for this. Or we take the other way around, huh? Basically, what the industry looks like is there is this huge monopoly, especially in the US. Everybody's using Revit. If we please just go to look at their data and do our stuff with it, we would already be so grateful. And so this is actually more of the approach that you see some other software tools take. Just try to massage the data long enough until it's good enough for your purposes. Do a lot of reverse engineering, and then if there's errors, just hide them from the user, because you want to give them the perspective also that IFC works. If you show error messages on every interaction with IFC, the confidence that end users have degrades. And a lot of the software packages used in coordination around BIM that depend on trust in IFC. So we have a benchmark question for that. Does the software report any errors during the import process? And again, trust me, there there are errors in these files. So are they reported? Well, the majority doesn't. It will just silently, yeah, do their best to reverse engineer their way around the issues, some on purpose, some not. Yeah, and I think that's an interesting observation that this benchmark highlights. So this is based on participants and not on and not normalized for software packages. So if there is, that's for most of the images I display. If there are a lot of participants using the same software, that kind of biases the results. So keep that in mind for the remainder of this presentation. And then I want to highlight this important part, also brought up earlier with regards to model view definitions. The standard practice also that also relates to this concept of federated models, and that's this notion of coordination. So everybody is happily modeling things. This is program of time, modeling things in their software of choice, exports to IFC, and then this coordination happens. You view these federated models, in some coordinated environment. It could be a common data environment or just software such as Solibri or Navisworks or whatever. And then what goes back is typically a BCF file, BIM collaboration format. So in the approach that works currently in industry, there is no IFCs being imported back, and that's also not, as we heard, what the software is certified for. So I think that's a good disclaimer to have in mind for this benchmark, because it stretches the limits a bit of what IFC is intended for currently. And that versus design transfer, which obviously has a need as well in industry. You can see an example here where somebody is working on some parametric design in Grasshopper, and then simultaneously sees that interoperate in ArchiCAD in this case. So that need exists, but it's it's maybe just a little bit too advanced for both IFC as a standard and implementation. So, looking at our benchmark, what software was actually used? No surprises there. Revit is dominating that. I'm a bit surprised to see FreeCAD in second place. I don't think that represents actual usage in practice. But, and then the other things, the other software packages, some of which showed up earlier. And then, some of these are authoring tools that you can use to produce an IFC file, and some of these are coordination tools that only take IFC, you use them for collaboration, and then you go back to the authoring tools to make the necessary changes. I wanted to make that distinction, but I didn't have the time for that yet. And so part of this benchmark included analytical file with some weird geometries. So what was exactly the purpose of that? Yes. So if we already concluded that a lot of the files contain invalid situations, here called schema permutations, like yeah, you combine certain classes, entities, call them, and you have some attribute values and relations to other things. And at some point, it's either valid or invalid in configuration. And that's represented here in green and red. But at the same time, when you import, that configuration, it may well be supported or not supported. And that doesn't necessarily mean valid, or it doesn't need to be equivalent with this valid-invalid distinction. There are invalid situations that are supported in import, but there is also valid situations that are not supported in import. And that you know that creates some landscapes within this total set of possible configurations of IFC that perhaps we need to look at. So for example, things that are valid but never exported, these also exist. Well, perhaps we need to remove them from the schema then, you know, so that at least other people don't waste effort implementing that if nobody is ever going to generate it for you. There might also be things never exported, but that importing software actually has implemented support for. But perhaps more worrying, valid configurations that are exported but poorly supported. The hope is, of course, that the majority of valid configurations that are exported are also supported at import. And then the interesting thing is what to do with the invalid configurations that are supported, because these exist, and I will highlight some of them in this benchmark. Should we make the schema more permissive, because apparently these are covering situations that are supported at both ends? Or should we make import more restrictive to really explicitly fail on cases that are invalid? And that's a bit of an open discussion. For now, first some background. We've heard these terms a little bit before, maybe boundary representations, polyhedra. In short, there can be, if you look at the geometrical side of things, there can be two ways of how you are going to implement support for IFC. You can do that as approximations by definition. So for example, what we see here is if you're familiar with IFC, you would say this is clearly an IFC revolved area solid, which means I have this cross profile here, and we're going to sweep it along a circular path for a while. There are two ways to implement this. You either say, okay, a circle, I'm just going to make, I'm going to create straight edges in there. I'm going to create an angle, an approximation of that. And you know, for this revolution, I'm just going to take some discrete steps, mirror that profile, and create the necessary connections to have the faces in there. You could also take this BWeb approach and say, hey, a circular sweep of a circular cross-section, that looks a whole lot like a donut. So I'm going to take this primitive donut surface and create topological bounds on that. which means that I actually have, in this case, a fully precise representation of that geometry. And we have a question for that. So looking at this analytical, set of geometries, do these kind of geometries look smooth? That's kind of a question that we were aiming to shed a light on the kind of implementation path of software too. And of course, this is not a one-to-one mapping also, because if you create a detailed enough polyhedron, it's going to look smooth enough for all purposes. Or you could implement it as a fully curved surface B-rep model, but still use a very coarse visualization mesh. So yeah, I'm not sure how well this question actually represents the implementation path of the software, but it's our best bet. And so for one particular geometry, a lot of people said that it's smooth, and very few people said it's faceted, and for some reason, hollow people said something else. But I think that's always the case with these kind of surveys. But that also traces back to this earlier. So I, for example, Revit and FreeCAD, they both have this B-rep model. So they will give you smooth. But it's correlated with the software used. Now, more related to validity and schema and some of the other things we put in this analytical set of files. So if you look at a direction, it says it's a bounded list, 2 to 3 elements of a type called IFC real. Some people might be familiar with it as a floating point number or whatever. So that means that the 0, 0, 1 is invalid because these are integers, so wrong. It also means that 4 elements is wrong. But these other 2 cases are valid. So 0, 0, 1 as decimal numbers and 0, 0, 2 as and we actually, if you look at an extrusion in IFC, it's defined as a direction and a depth as 2 separate attributes. But at the same time, this direction does not need to be normalized in IFC. So what if we have a non-normalized directions, it's longer than 1, and also at the same time have this depth? How is that handled by software? And we had this is the geometry that was supposed to test that. So some implementation would make it the same as the other cubes, and others that would not normalize the direction would make it twice as long. Let's see, and yeah, well, as expected, that's why we put it in there. The minority of implementations did not normalize length, and for some reason another implementation made it completely flat, but that might have been something with the participant, not with the software. Yeah, but it doesn't it doesn't stop there. Huh? Like we see in the previous presentation, there's this whole layer of constraints. We have the types, we have their cardinalities, and then we have their where rules. And some of these domain rules are very simple. So if we say something is a positive length measure, well, it better be greater than 0. And so what's then invalid? Well, -1 is invalid, 0 is invalid, but also 5 as an integer is invalid, but 1 is. And we also have this in our benchmark. We had one negative extrusion, so a negative positive length measure, and a 0 extent positive length measure, and the question is, you know, what should the software do? And for me, it's also not really. I don't necessarily say there is a right or wrong here, because what certification does, for example, if your software is certified, you're basically making a statement. I can import valid cases of IFC pretty well, but error handling, performance, these kind of things are not tested at certification. So yeah, what are we really saying by generating invalid by generating invalid configurations? Well, that's open for debate. The interesting thing is that the majority really just gives you the just displays the invalid shape for you. And perhaps just the most important thing to take away from this is that by allowing by not certifying this kind of error handling, you see these discrepancies between software implementations. So one user sees a box, the other user sees nothing. Yeah, if you're a contractor and you need to order an amount of concrete, yeah, you just want to know if you have to build that box or not. And our end users are also not so capable to to validate their files or to understand these kind of ambiguities between the implementations. They don't want to be bothered with that, at least. So I really think for practitioners, these kind of issues, can be problematic. Where one software says that, the other software says the complete opposite. Excuse me. And then the interesting thing is that these constraints, these where rules, these main rules, whatever you want to call them, can be really arbitrarily complex. So they can refer to functions. I copied that function here for reference. I don't intend you to read it all, but these are really small, limited, Turing complete procedures embedded in the standard, and the complexity of that to implement that is just breathtakingly high. And as said before, basically nobody, at least the current open source offerings, for example, they just completely disregard these. And that's what we see here, for example, that what this rule is trying to prevent is that if you have an extrusion, you define a cross section, and you don't want the extrusion direction to be parallel to the definition of your cross section, because then you would just slide that thing forward. So that's what happens here. This ellipse is swept parallel to the ground plane, and this is forbidden by this wear rule. And again, you see that yeah, most software will make an effort to just show that to the user. It was this complex wear rule, and then were able to see that object. And for the simple wear rule, I just tested whether the extent was positive. 30 people were able to see that particular element. So apparently there is also a distinction in what kind of wear rules are implemented in software. The more complex ones, there is even a smaller set of software supporting it. Yep. Some of there is a whole bunch of domain-specific cross-section definitions that are not derived from this step part 42 that we invented our own. And one of these parameters is a fillet radius, so that if you have this eye shape, that these two faces kind of blend nicely together. And yeah, not all software supports that, but the majority here claims support for that. So how representative was this analytical set for end users in practice? Well, we also had two more conventional actual IFC models from practice that we encourage our benchmark participants to experiment with. And these are also not perfectly valid. So for example, this updown.ifc has some inverse cardinality constraints violated. So if you have a property set, it can only be used by one type object, but this one is used by two type objects. I don't think anybody would lie awake worrying about these kind of validity concerns, but just as an example that as we've said before, none of these files are perfectly valid. And if we don't set rules on how to handle invalid situations, we are allowing these different implementations to diverge, and that could cause problems. What kind of geometries did we encounter in these files? Yeah, no surprises there if you know a little bit about IFC. Pretty much everything is an extruded area solid or a faceted EREP. So in that sense, perhaps the kind of geometries are not so representative, the kind of analytical geometries are not so representative, at least the more advanced ones, because what we see is that both export and import kind of focus their effort or kind of degrade to the kind of representations that work. So the more advanced kind of parametric suites are not used that often. And it's that tessellations, for example, are used because yeah, they're just more, the challenge is bigger that they are supporting that influence. But that means that you lose kind of efficiency because a nice suite is a couple of statements, and approximation of that is maybe 10 to 20 megabytes of explicit points and faces. And you also lose the semantics. If you have a nice sweep, then you also have a cross-section profile. So you have the radius of that, for example. And you have the length of this path. So it's a much richer representation of the geometry. And yeah, these kind of issues are also being reported. So here you see Ian complaining. So I generate a beam, and in one file I have it lying on its side, and in the other application it's standing up. I think I'm not a structural engineer, but I think that's a concern. If you don't know how your beam is oriented, yeah, I would be worried about that. So yeah, I think I already talked about these conclusions. So invalid export is a fact of life currently still, due to the complexity also of the schema and how importing applications deal with that varies. Thanks for your attention. Any questions or no time?
So, thank you, Thomas. Well, we can postpone some minutes to the coffee break. So, do you have any questions? Okay. If you have more questions, you can also ask later after the coffee break. So, thank you, Thomas. Here is your letter.
Thank you
very much. And so, if we have no questions about IFC being IFC issues, so we can move to the coffee break and we come back later in 15 minutes to follow our program. Okay, thank you. Yeah.
6 people. For the box, we like.
Okay, we can start again in a while. I have a quick question in the meantime. Is it the case that any one of you was given the secretary a pointer, a spare one, that we lost? No, do you? I will follow looking for it, sorry. Is it okay?
Should probably ask that again if everyone's in the room.
Yeah, you are right.
Yeah, otherwise still lost.
Yeah.
Gonna be the last person who has it. Murphy's Law.
It's okay, so everybody's coming. Okay, so now we move to the final part of our first day. And as the first presentation of this session, we have Anna. She's really happy with standards and she really likes standards, so she will present us some more than just CityGML and IOC. And it's to you. Thank you.
Thank you. I think Francesca tries to pretend she's really nice, but she gave me this presentation because she knows I actually am not a huge fan of standards, but we'll get there. But I have worked with them a lot. And mainly in the context, I will say, so I'm not going to pretend to know everything about every standard, but I know a lot about the metadata because that's my main passion. And I also know a lot about how they model roads, so I work with that a lot. So we'll kick off. The one I probably know the best is Land Infra and Infra GML, which is the GML encoding of Land Infra. Unlike CityGML, they gave it 2 separate names, which is super helpful. So we worked on a project in the group. We have Kavisha, she's now finishing up her PhD, but she was in our group. We have Ken, who many of you also probably know, and then of course Hugo and Nantine. And so we basically looked at IFC, Land Infra, CityGML, and that resulted in 2 separate papers. So Land Infra is also an OGC standard. And the way it became an OGC standard was it basically succeeded Land XML. People were using Land XML, but they wanted a standardized thing to use because standards are great. And instead of being XML, they then also went to a GML encoding. So they did a subset of Land XML, but the Land XML working group worked pretty closely with OGC to do this. So they do topography and subsurface modeling, so that's what they're trying to tackle. And they also have a big survey module as part of it, and infrastructure modeling and future construction planning, so that's the domain that they work in. So it's supposed to be for land and civil engineers, and they also deal with administrative units, so they borrowed a lot from, I will be talking later about LADM, but they borrowed that concept from there. And they deal in land parcels, condominiums, any type of infrastructure measuring construction units. So it has 10 classes. The only mandatory class is land infra. And then from there, most people use the facilities. And under facilities, you get roads, railways, and all of your infrastructure. And you can create projects and plan for future infrastructure development, above ground, below ground. So that's what they deal in. It is very extensively documented. So if you ever get a chance to read the land infra documentation, it is very, very detailed. So they have the UML conceptual explanation of the land infra part, and then they have 7 parts of infra GML supporting documents. And each of the classes is defined by a specific infra GML portion. But it's pretty new, but it also has, as of the beginning of this year, I haven't checked, but it has no software support and very few sample data sets. So it's pretty hard to work with, but maybe that's just because it's a baby, so it still needs to grow up. So then we looked at it because one of the proposals of land infra was it was supposed to be a bridging gap between IFC and city GML. So it's supposed to do that. So we decided to look at that and see whether this was the case and whether we can provide some sort of support with city GML for land infra. So the first thing we did, maybe some people have seen it, but we did a mapping and between the standards and also looked at the broad overview between the standards to see where they were similar and where they were different. Not surprisingly, given that they're both OGC standards, land infra and city GML have a bit more in common. But if you want to see so we go into huge detail for all of these categories. So if you want, we have a paper. It's got a very fun name, the Land Infra Standard and its role in solving the BIM GIS quagmire. So, edgy buzzword. But yeah, so if that's something you're interested in, we have a full deep dive on that. So we created a ADE for City GML that incorporates land infra. And we did this for everything except the surveying class because that class is like a whole league of its own. But all of the other classes are implemented. And everything is publicly available, of course. And with that, there's also a tool to convert between infra GML to city GML, and as well as the schema for the ADE should you want to use land infra. And again, if you just go to our group page, you'll GitHub page, you'll find everything. Or if you go to our group website, we also have links to all of this. So I'm not going to talk about Inspire too much because I'm going to take a wild guess and say most people have at least heard of Inspire or in some way dealt with Inspire, especially if you're in Europe. It's a European initiative. And it's got 36 spatial data themes, and I think it's got 28 participating countries, but somebody might know better. One of the reasons I do like Inspire a lot is because they have very extensive metadata support. And I should have said land infra actually does have support for metadata, unlike City GML, where it's very limited. But with Inspire, they have a pretty active community working around it. I also saw some research from a group in France. Their name is like Mind, but then there's like a ND in there. So I don't know exactly how to pronounce it, but they are working specifically on BIM and Inspire integration. But maybe specifically here, so Inspire provides UML diagrams for the thematic modules. And because they have a pretty active community, I saw they have an incentive now, and it's to have as many encodings as possible. And they have an open toolkit for UML to JSON, for example. So they are working with multiple encodings. And it's to have a common language for the exchange of different environmental data within Europe. So then there's the land administration domain model. I know it mainly from its incorporation inside land infra. That's mainly because it's an ISO standard, and I have a really big issue with ISO standards because they're not open. So as someone in academia, I have access to it, but the layman doesn't. So I don't find that very good. But it's land infra is open, and so they have pretty extensive documentation of how they use it. So like it says in the name, it's for land administration, shockingly. They have the abstract conceptual model. They have some samples, but not very many. They're also very UML heavy. And again, because for me it's basically a closed standard, I have not really interacted with it more than theoretically. The big basis, what they do though, is they try to come up with a common terminology, and it's also a base for countries that want to look at land administration to have a common language and to start a common group. I know I was in Singapore, so even Singapore is looking at something like this. So even though it's started development out of Europe, the idea is that it should create a common terminology around the world. It does have metadata support. It's also under ISO 915, which is the main geospatial metadata. GBXML is probably my favorite one on the list because they are not a standard. They are a de facto standard. And so it's a spinoff from a green building studio, which is a company. They're very open. It's everything they do. So they call themselves a standard. I'd say they're an open standard, but for me, standard is a dirty word. So I just say they're an open community. It doesn't get updated that often because I feel like it's a pretty niche topic, but if you access them, they're very active on GitHub. They have a forum. They seem to just be a group of really passionate people in this field. And so the idea was they felt that IFC had too much for what they needed. So they basically took the subset of IFC and made it specifically for energy analysis and to build energy efficient buildings. And they deal a lot with HVAC, heating, ventilation, and air conditioning models. And that's kind of their main domain. And they facilitate the transfer between different BIMs, basically. So that's what they do. There's quite a bit of software support for something that's, I would say, relatively small. But they, like I said, a very active community working on it. So an example, they online, they have a lot of documentation how to get from Revit to train trace, which is modeling of energy. They have a lot of support, Autodesk, Trimble, Graphisoft, and Bentley. And it works in over 50 modeling tools. And just looking online, they keep adding more and more. So they're quietly working, but they have a lot of documentation, a lot of samples. So for me, they're nice. There's indoor GML, which is, most important thing, metadata. They actually support basically all metadata, but they don't call it metadata. It's all in its own classes, but there is support. They even follow lineage and things like that. I know everyone here is super passionate. So yeah, so there's indoor GML, also an OGC standard. They actually have a pretty active working group as well. They are very careful to distance themselves from City GML, so they do work with the City GML working group as well. And the idea is they don't want to overlap too much. So for example, while they deal with geometric representation as well, they actually advise people to use City GML if that's what's more important to them. So they're way more interested in this idea of cellular space. So say a room is a cell. No cells can overlap, but they can share boundaries. And then they're very interested in the semantics of that cell. And the semantics can be different based on your use case. So you either say this is a room, this is a hallway, or an example they use is they have different Wi-Fi hotspots. So you can categorize cells based on Wi-Fi hotspots. And then they care about the topological representation. So they care about the relationship between the cells, but they don't really care where the geometry is. So you can have a totally valid indoor GML data set that has no XYZ coordinates. So it's just a relationship between these cells. And you can have multi-layered representation. So you can have a semantic cellular topological model based on the type of rooms, and nested in the same model, you can have Wi-Fi zones, for example. So that's what they're after. They have a metadata module. You'll be happy to know. I think you've noticed our group is pretty biased towards JSON, and I'm not going to deny that or hide that. Also coming out of our group, mainly Hugo Ledoux is working on it, but there is a JSON implementation of indoor GML, and that's all, of course, openly available and accessible, and there's a validation tool for it as well. So all that being said, I have to do a small cautionary story about standards. I think they're often important, but people get lost in them. So they take ages to evolve. So for me, the best example on the list has been GBXML, but that's because they're not a standard and they just update as they go. And of course, we're still waiting on CityGML version 3. Sometimes they overfit to a specific case. And then therefore it's hard to have this interoperability because everyone is so focused on their domain. So it's too, while Stelios said constraints are good, they are good, but sometimes they're too constrained. Contribution is not transparent or easy. I especially say this in relation to ISO, especially if we're gonna have legal requirements around ISO, this should be an open process and it should be publicly available. And I don't think you can justify having a standard that only has UML. You have to have sample data sets, you have to have at least a viewer or something, and you definitely have to have metadata. So, but yeah, so that's me. Hopefully it was relatively painless. But yeah, that's my group. So if you want to blame someone for this presentation, blame my group.
Thank you, Anna. Any questions for Anna for this presentation and other standards in general? Any comments?
Everyone's asleep.
Okay, they are convinced. Okay, thank you. So we go to the working session of today. Yeah. So this is Jordi. He's helping us in integrating the test of the benchmark. So he became very confident with the tasks and the type forms and so on. So we will present you the workshop part of today, so that if you like, you can take your laptop and your software and do reproduce the task in a shorter way and have a look yourself at what are the issues with the standards. So please, Jordi.
Yeah, so exactly. So my name is Jordi Valins. I am a master's student in geomatics at TU Delft. I've been working with Francesca recently, and I'm also working a lot with Balázs that you have met during the presentation on CityGML and CityJSON. And yeah, I want to introduce you the benchmarking workshop. So we have already heard about the benchmarking, of course, and we've already seen many results on it. But now it's time to do something practical with it. And in that way, you can really get familiar with it yourself and also find out more about some problems or maybe also some good things that you can encounter with IFC and CityGML. So that is really the aim of this workshop. So I guess most people are either more familiar with the geospatial side or with the architectural side. Maybe some people are in between as well. But the goal is really to bring everyone closer to each other, I think, and get more understanding of each other's field, and also just being able to look more specifically into the problems that you can encounter with these standards. So first, again, still a little bit of theory. So you've already heard of the test, but more specifically, what has been tested again is importing and exporting functionalities and the management of georeferencing, geometry, semantics, and other functionalities such as editing functionalities or analysis functionalities. So this has all been tested during the benchmarking, and we have for today prepared some online forums also that are slightly different, but that will address all of these points that you can investigate for either CityGML or IFC, and I will show you where you can find the forms later. Also about the data that has been used for testing. So there are generally two kinds of data that you can
find. And that's data that's either created in an academic environment, which is like pretty much perfect normally, but that deliver unrealistically positive results for software often. And then there's also data that has been created by practitioners for real-world use. But in here, it's likely that there are some inconsistencies within the data. So in order to find the middle way, what the team has done is taken data sets that are modeled by practitioners. These have been investigated, analyzed. Some main problems have been removed, and in that way, the best data has been selected to use for the tests. So generally about the data, well, both for ISC and CityGML, it was a requirement that they wouldn't have many problems with the geometry. Also, they should be quite complete, different practices, and also very relevant for CityGML is different LODs. So what has been tested is data sets in LOD1, LOD3, or what we are going to see today is a data set that has been using both LOD1 and LOD2 at the same time, which was on Rotterdam, which was introduced a little bit before. So now about the actual task, what we would like you to do. If you do not have a laptop, it would be nice if you can maybe team up with some others. So there are two different tasks. So one of them is on IC and the other is on CityGML. It is up to you which one you would like to do. I would suggest it would be maybe best to do the one that you're least familiar with right now. You can also do both if you're fast enough, but we will have to see about that. But as for the actual task, you can follow this link or that link. And over there you will find the online forms which contain many questions about the aspects that I mentioned before. It should be quite straightforward. And what you're supposed to do is answer these questions while using your preferred software. As for the software, maybe not everyone has appropriate software installed. So I have some software listed that I would suggest to use in that case. But not all of them can be downloaded very quickly, especially I noticed that the internet connection here is not too fast with so many people. So what I would suggest, for example, is if you want to test BIM and you don't have any software, it would be quite easy to install this one from AP USB Viewer Plus, or for CityGML, the 3D City Discover, or CK Viewer OSO, for example, are very quick to install. So if you go to the website of the task and you download the data, then you can try to import the data into your preferred software, and then just try to follow the questions. Then there's also the website on the GeoBIM benchmark that contains more information about both the task and data description. So if you have questions, probably you can find a lot of them inside there, but we are also here to answer your questions if you cannot find anything or something is taking long, or just don't hesitate to ask me or Francesca. So, all right, that's it. I think you can try to follow these links and try to start.
Yeah. I just asked add the logistical thing, so we will stop at 4:30, so we can move on. So I hope you will be able to finish the task, but in this way, if you are not able, don't worry about it, and you can either finish it later or not, as you prefer. And, okay, so we can start.
Yes, I cannot connect to the Wi-Fi. That's where it's Amsterdam with the lower.
Yeah.
Somewhere it said that you have to use a calculator to sort of.
One more thing? Or
Yes. No, it's a small. It's
two more things. To connect to the Wi-Fi, you can use the AMS net, and the password is Amsterdam lowercase, no uppercase A in the beginning. And I ask you once more, does anyone have the pointer? No, there's
Misschien willen we te veel mensen met daar nu zijn, dat denk ik. Dat ben ik bang voor.
I can just mute it.
Ja.
Ja, nu werkt het wel. Ik hoop dat het nu ook niet goed gaat of zo.
No, I think it's okay.
You let me
Okay,
know.
everyone. The time is up right now. So can I please have your attention at this moment? I would like to say a few more words. No, it's fine. It's okay. I don't. Okay, so yeah, this has been quite a short period. It's about 1 hour only that we had for the test. So I think some of you did finish some testing. Others had some more problems. But this is okay because what the workshop really was about was just getting more familiarity with these data types and on how to use them and what the problems are with them. So I at least hope that you learned some stuff from this, and also maybe you can use a bit of this knowledge in the future if you would like to try it for yourself when you're at home or something. Try to work with CityGML, CityJS, and IFC. But I wanted to ask you if anyone wants to tell me what's something they have noticed during the testing, or it's also something that you can mention during the discussion later. If no one wants to say anything, that's also okay.
Does anyone wants to share any comments on the work that we just made?
Well, we like about the question, what to do with how to make GeoBIM everyday reality, right?
Okay, so now we are on the next following
That's the
part.
discussion.
Oh, yeah.
So I think we
It's
can go
okay.
on to that, right?
So thank you, Yardi, very much
No
for
problem.
guiding us. And now the stage is to Claire that will explain you.
Yes. I have.
A quick introduction from me. I'm Dr. Clara Lull. I work at University College London in the Civil Engineering Department. I've been working with GIS for a long, long time. And those of you who struggled with the exercise just now, that's normal for GIS data, right? It doesn't ever, really, ever go perfectly. Why should GeoBIM be any different to normal GIS? We wanted to flip this session a little bit for the last hour of today and take advantage of having a really interesting group of people in the room. I was lucky enough to be involved in this GeoBIM benchmark project. I've been lucky enough to see who you are and where you come from. And we'd like to sort of learn a bit from you guys now, in a sense. So what we're going to do is a little bit of a group exercise, just to get your brains ticking a little bit for the last hour of the session. The group exercise is based on some work we did for a Euro SDR piece of research, which Jantine is going to explain in more detail to you tomorrow morning. So I won't go into much detail now, but just for now, one part of the research that we did, about a year and a half ago now, I think, was we were asking people, okay, GeoBIM, here's the idea. What are your barriers? What are the issues that are stopping this idea becoming the great thing we all think it could be? So we did a survey, and I think Jantine might explain a bit more about that tomorrow morning. We'd like to kind of repeat that as a mini exercise with you guys today. So we've got a whole mix of people. The general question is, what do we need to do to make GeoBIM a reality? So the benchmark is only part of that bigger process. So here's your instructions. You're going to feel like you're back at school. For two reasons you're going to feel like you're back at school. Firstly, you have to do homework. And secondly, we have pretty colored pens. So you're going to write stuff. So what you need to do is form groups of 5 to 6 people. Turn the chairs around and form groups. Ideally, don't work with people you know. Let's try and get the group chatting a bit and mixing up together. So once you form the groups, find a note taker or a spokesperson, and whoever that is can come forward and pick up a big sheet of paper here and a colored pen to do some writing. And pick one or more of the challenges that Francesca has very conveniently placed at various locations on the wall. There are 6 of them. 1, 2, 3,
4, 5, no, 7 of them on the wall. I will put them on the screen in a minute as well so that you can see what they are. You can do one of two things or a mixture. You can either take one challenge and spend 20 minutes discussing it in detail in your group, or you can take more than one challenge and discuss it in less detail. The important thing is that you put your thoughts down on the paper and be prepared at the end of half an hour. I'm going to go down round the groups and you can all just give us a quick summary of what you've discussed and what you think. It's a very open discussion. There is no right answer to this, so any ideas that you have are very welcome. What we're going to do as well is, whoever your note taker is, hopefully will have good handwriting, because we're going to collect all the papers at the end and summarize everything and then circulate it to the group in the next few weeks. So whoever your note taker is, ideally nice handwriting, please. That would be very helpful. So each group spokesperson, basically each group will take notes and present the ideas. We'll collect everything and summarize them. Right, so the timeline is more or less, we'll take 5 minutes to get everything set up, 20 to 25 minutes of discussion. It is short, so maybe you do one question or two questions. And then another sort of 20 minutes of just going around the groups and you telling us what you've found. We've left everything in terms of the questions quite open. And in fact, I added another one to the list that isn't on the wall, another challenge you'd like to address. I will keep this screen there in a minute. For now, groups, get going. Try not to work with people you've already met, if possible. Turn the chairs around, introduce yourself, get the spokesperson. Swap across the room, try and mix with different people. Groups of 5 or 6 maximum, if you split. And whoever's spokesperson, come forward and get some pens and paper. We'll collect them up at the end.
For us. First bullet is about understanding of GeoBIM, why it's yeah.
So I'll put the challenges on the wall. Go around the groups, introduce yourselves to each other, and pick a challenge or two and start.
We want to wait here,
Yeah.
if it's fine.
Yeah, okay. If you've got any questions, just wait.
Right into the street. People can hear these questions. Do you want to start?
People will participate to your discussion from remote. Good.
In the middle of the room, like they can see everything.
Like they will hear you. So
Yes.
How many do we have online? Maybe they can do a group online. Is there a chance?
yeah, well, I'm not very expert about this, but I think
So,
it could be
online people, feel free to email us ideas.
Okay, maybe everyone should introduce themselves. I already introduced myself, but my name is Jordi, and I'm a student in geomatics at TU Delft. Very affiliated with the 3D geoinformation team. That's about my expertise.
Okay, I'm from Sweden. I'm an industrial PhD, so I did my PhD at Lund University, but I invested all that today back in the industrial agency.
I'm Tim from Dresden, Germany, and I'm at also the University Research. We also decided to tackle the challenge of integrating BIM and GIS. Me personally, I also are involved in a bit of photogrammetry, so not all the time GIS, but also some other stuff.
Yeah, sorry I forgot to mention, I'm more on geodata. On the business side, yeah.
Well, my name is Martijn. Work at a firm that does both acquisition for real estate and building it themselves, so they're mostly self-reliant. And I'm more on the real estate side, where I'm trying to mainly in charge with a company to combine BIM with GIS. Most out of my own interest, so it's like seeking for silver and finding gold with combining those two. So,
my name is Gordon. I'm from Brooklyn, and I work in a government agency that distributes data. We're also a national mapping agency. And well, sometimes it's an IT architect. Work with different things, and we also work on GeoJSS, so GeoJSS stuff.
My name is Lorena. I'm from Germany. I work for a GIS company that does GIS and data integration. And my background is mainly GIS and geography. And I study geography at university.
It's a diverse profession.
Yeah.
Does anyone have any preference for the question? I think we only should choose one. Oh, only one? I think so. We can start with one.
I like the first one and the second one from right on. So what are lack of understanding and what are three significant factors? I personally think those two are my questions. Yeah, that's good. Okay. Oh, now one of those?
Yeah, sure. Yeah, go ahead. I think it's okay. Yeah, it's okay. I think.
So like three factors maybe?
Yeah, sure. Yes. Do you mind writing the question of this? Or maybe not the full question. This is the three significant factors.
Three significant factors. Push. Yeah.
You may write. Maybe we can write many things and then maybe in the end choose three or something.
Maybe give them a star or something.
Yeah, that's a good idea. Okay, she would have things also like communication, promotion. That's quite straightforward, of course. It's a start. Yeah.
I guess maybe one thing is kind of workshops like this one where you bring lots of different people together from all kind of different backgrounds.
It's important.
And also to have a working example that's really something that's implemented, so you can see.
It's a real application.
Yeah,
to show.
Really show.
Yeah.
Because it's easy to talk about, and it's so hard for people to really understand what it means. Yeah.
It's not abstract.
No, exactly.
Yeah, I think I want to see.
That's a very good one.
Yeah. So, working example,
use case.
working use case.
Yeah, that's good, I think.
Yeah, because it seems that we have these different communities, but if they don't really know about the other community out there,
find themselves.
It's one of the things I noticed within our company, and also students that people that I've studied with, is that mostly it's a very niche market of knowledge that you need to have if you can even understand what's possible. So you need to have like a construction. You need to have knowledge of construction, GIS, and also IT, because the tooling is not really readily available to implement this concept. So that's something I noticed.
This came to think of it, we have this prototype. We showed it as well. We have this cultural night where people can come and see what we do. And I talked to this GIS guy, and he got a new job in construction industry. One in there know everything about GIS. So I think there's also a need for people to change between communities and be some kind of ambassadors to use promoting GIS that is within construction.
So again, like you need to combine knowledge from a lot of different fields.
Sorry.
Oh
yeah. I just wanted to say my degree is geomatics at TU Delft. We are in the faculty of architecture, but you can tell that there's barely any interaction. We are a very small group actually. We have 25 students every year in architecture, a few hundred, I think, and we are very insignificant. I'm also not sure if our own degree actually tries to reach out to architecture. So it's really a problem at our university.
Yeah. So like the fact it could be, creating overlap with education, GIS, architectural.
Maybe some way how would you say that? Yeah, maybe just education in general. Yeah, interchanging education.
Just supplying the education to even do something with GeoBIM.
Yes.
Shall we write?
Maybe like your interdisciplinary education.
Development that take place among bigger budgets. It's hard to achieve because one thing better to make the city also the city administration
Just like any software to become open source, or do you mean something?
I mean, that's not that won't happen. That's clear, but at some point it must be can be beneficial if the open source have some open source development or try to promote that.
Try to create some connections for some new software. Software is also quite separate, except for some viewers. Analysis software and stuff. But the software is complex software. It's interesting.
I don't know if like QGIS is open source. I don't know if, but it doesn't have any implementation for BIM models. I don't think so. At least not that I know of. But that's something that could be, maybe that you could be involved with this concept.
Yeah, that's definitely possible. And also create QGIS plugins, like for city judging, for example.
Yeah, like you
might be difficult, but I mean it should be possible.
Yeah.
I think plugins are also good, and if you have a software that's more BIM specific, then have plugins to bring GIS data and not the other way around.
Oh yeah, you could write it down also just plugins.
Yeah.
I don't know how else write it in a good way. It's quite difficult.
There's some examples. Try to get some funding for open source software projects.
So it mostly comes down to the available tools that you have.
What?
Software tools.
Yeah, maybe software tools that support this kind of data. Yeah. Do you want to add open source to it? Or? Maybe live in brackets or something?
Yeah.
So ideally,
Yeah,
but
idealistic.
Different trees, CO2, there's pollution, stuff like that. There's a lot to do over because you need to have levels because the higher you get, the less pollution you have. So those are the stakeholders I think. If you go back to who is responsible for keeping it safe, that's the ones that should be addressed.
No, that's right. BIM and GIS data.
Sure.
Oh, there's 3 factors, right?
You want to start? Yeah,
Time for another question.
yeah, I think it's fine also to think about something. Some of the answers are already also right. Seeing some other questions is something. Maybe the high cost of implementation, like how would you against issues in the best? How would you be able to do that? I'm not very familiar with companies, for example. So I don't know if you
Research projects. How will you force companies to participate?
No, you can afford them, you can stimulate them.
You must show the advantages somehow.
No, mostly not for university, mostly like well, we have that too, I think in other countries, but you have like a degree under university, it's like and they mostly just get people and knowledge from those schools. But university is not really. But that I think that's like this initiative with they developed. It's a great initiative to at least get the ball rolling because they have another mindset to investing and building these projects instead of just a corporate company that actually has to pay the man hours to develop something. So I think that universities have a leading role, and that once that's at least implemented enough, we're getting a result. Then maybe the larger companies like Swaco or something, they are actually interested in implementing it. So just a concept. Commercial companies don't really do anything with it unless it returns on investment.
They don't really want to take the risk.
Yeah. So I think universities have a main role in that.
Yeah, how do the universities get all this money? Sometimes it's also coming from this question.
Yeah.
Some specific research. And, I don't really know how do you really persuade.
Yeah, this is like with the they developed, it's mostly subsidized through investors like a company who subsidize projects for the developed, but also institutes like Kadaster and mainly pay for these kinds of projects, right?
Yeah, municipalities.
Yeah, public institutions.
True. Municipality of Rotterdam also.
Yeah, underground. Yeah, at least if I read the website for TU Delft, like the Kadaster big stakeholder in this project.
So, I don't know, I don't have too much knowledge about how you could do that. Like, it's hard, I think it's hard. Because like you already mentioned, like at first you have a good idea, but no real implementation yet, so companies but also if you don't have the help, then it's also hard to get new implementations.
Yeah, right.
So it's a barrier.
Yeah. The main problem with it is that in the end the data that you produce has to be, to some extent open source. And if you have a corporate business that invests in this kind of project, it won't make the data open source. And usually, why would you if you paid for it, right?
Exactly. Usually it doesn't happen.
But as you mentioned, the cadastre is involved.
Yeah.
Technology is a kind of solution that goes with changes.
Yeah.
That's a point for the sector to put some legislation.
Also, it might be a little controversial, but if you are obliged to provide the same with data about buildings, it has to have a certain
I thought I read something about it. That I think the government in the Netherlands had made it like a legislation that all towns and cities should at least make all data open source. Something like that went past like 2 years ago. So from the government down to citizens and towns, they kind of forced them to make all data open source. So maybe that's more like that it's on one part is vision from a country to make everything open source, and also the initiative from universities combined with the stakeholders like cadastre and maybe some corporate businesses. Maybe that's something that's how to deal with high cost implementation.
It's also kind of related to the discussion that I was having before. GS datasets are more often open source than BIM. Supposedly it's quite hard to maintain that, even for testing purposes. Also for this project, more difficult.
Like GIS data is difficult to maintain?
No, the BIM data.
Oh, the BIM data.
It's usually not open. GS data is very often open. CityGML data was all open data. The BIM wasn't all open.
Project firms don't have any stake to public side that the BIM should.
Yeah, exactly.
It's mostly their intellectual property.
Yeah.
But I don't know why that like you have companies that want me. How do you say it in English? You have like these KISS companies that set out a cancel property line, outside. You know what I mean? The name of it.
Yeah, maar ik weet niet hoe je
Ja,
I
landmeetbedrijven.
don't know how you say it in English. It's like measurements. Land measurement.
Yeah, land measurement company. They have to publicize the data, right? But I don't know why are they forced to do it, or do they have some kind of stake in doing it?
Yeah, sure. I don't know if there's any. Yeah, maybe also another question.
So that's the government again, or the
That's standard standards in GeoBIM. It's an interesting one also. I think there's no standard that can really work well with the yes. Yeah, exactly. It's very complex. Yes. I don't know too much about IFC. I should have mentioned that in CityGML and CityJC you can store quite a lot. So the information is probably not really perfect. I think BIM is way more complex.
And you would then have
standard for each use case, but then you can also say that what to do.
It's also related to someone's question earlier today, like for something, probably it's before city GMO file. That's all part of it. Yeah. And also, I think attaining BIM information on a large scale is quite hard in general because it's about the insights. So how can you measure zero into someone's place? Yeah. For homes, that's pretty much impossible. No idea, that's really impossible.
It's also the question what data you really need for a BIM model. You know, like a BIM model has the exterior, the outer shell, the model. It also gives you the geometry for all the external objects. Do you really need the data for which interior wall there is and which bedroom it is?
Probably not.
Yeah, it's probably just a lot of bulk data that only makes software slower, you know, that really uses the geodata.
And we have discussions about using those MDV, model view definitions.
Yeah.
Because that's kind of making a view of the BIM model. So if you have been doing some tests with building permits and trying them using the BIM model as a source for your data, should be used then in building permit process and automate.
Yeah.
So then, if you then create a model view definition that just takes out from the BIM model, in the building permits, kind of scales up necessity some parts of it. And that makes it much easier because then you don't have all those things in the BIM model that have, that would be and creating those things and then having an IFC model that is made in the correct way so that you can use entities that it includes parts that the entities as it's supposed to be. Yeah. Because that's also a problem. You need really guidelines to include your BIM model to be able to use it as a source.
Yes, maybe everything in a BIM model that's exterior should be implemented, and everything that's interior is probably not necessary.
In most cases.
I imagine, for example, for energy demand calculations, it would be nice to also know the internal structures. It will become complex.
Yeah, last this is for a complete neighborhood or something. More things like prediction of your creating a neighborhood from scratch.
Yeah, right. It's a very specific case. I don't know if there are.
But also for the indoor navigation for finding 5 comes to
Yeah,
I heard it.
Yeah, that's also.
Don't you have with IFC, don't you have like the analysis part of the IFC file?
I don't know what it is.
Okay.
ADE is also terminology if you use.
Okay.
It's an extension. I think something else.
Yeah, maybe. I thought there was like a part in IFC that's only about, you know, the energy analysis and you know, those kinds of calculations. I can see that you maybe if you export IFC, that you don't have to bring every data about what kind of installations you have, what kind of interior design you have, maybe that you do like a calculation while exporting to IFC, and that you would take the result of the calculation in your IFC model, that you don't have all the backlog data, but only the result of the calculation. But you could use that value to calculate like the demand, what kind of geo analysis would you need internal parts for. I don't know.
I think we say it's not necessary to have one standard for GeoBIM. Try to just integrate two different standards.
No, you know that the question was if you need all the internal information for a BIM model, because you would like to do analysis on how much power you need, like install some solar installation. I could also see if you would just, while exporting to IFC, that you would already calculate the energy consumption of the building, that you would export that to the IFC instead of internal. That would save a lot of data and still give you the same result. Yeah, while exporting already calculated.
That must be easy to do.
Make a kind of setup for this process, enriching the other information.
Yeah. Now that I think about it, I think that towns and cities are required to have revisions of everything that's built in their archives. You can just go to the archive, like one of them, and say, I want the drawings from that building. That's the same now with BIM models. You have to give them.
About 5 minutes more, so if you have you need handwriting, whoever that is. I'll come back in about 5 minutes and we'll go around the groups.
If you build something like in Amsterdam, if you build something in Amsterdam, you have to give a revision of your as-built project BIM model to Amsterdam. First, that was always just a CAD drawing. Now it's probably BIM model. So maybe the gathering of BIM data is not really that much of a problem in the future. Because like Amsterdam would have a revision of every BIM model that's been built in that city.
Even for buildings that they don't own, which is just for the buildings that's city, so to say.
Yeah, if I want to know how a building has been built, I don't know how that's your company, but if there's a building that has been built, there's an archive in Amsterdam that has every drawing or CAD drawing from the building. And I think that our
private buildings.
Everyone can access? Yeah, it's public. But it's mostly, still paper, so you actually have to go there physically and make copies, and it's really.
So that's one of the factors which maybe.
Yeah, but if they just instead of
digitize.
Yeah, but if you have to give an as-built design that's more like Amsterdam, if you require a company to just give you the BIM model and see instead of just drawing what's right now. Yeah, but it's already it's already required. But I don't know if it's that's the thing.
Yeah, I think so. But I don't
Generally, also for that's what you might get ownership information.
Okay.
Only if you are allowed to, if you are the owner of the, then you can get the ownership information. It's kind of.
You have the information, but you can't give it out.
Okay. Oh, and then you just go to the cadet and say, I want the information on this parcel. You pay like €1 and you get all the names. So that's privacy.
It is something that's strange if you think about it. People could misuse the information.
Yeah, but that's.
But it can also be used.
Yeah, it's like part of my work. I just check with the candidate which parcels are from who, and to draw something, you have to do a bit on a crowd. That's part of my work. But I didn't know that's in your country. That's not really the thing.
Germany also issues some files where you can see which land is owned by who, but I don't know who can purchase them. I'm not sure. You have to be authorized or something. I don't know. I've seen these files, but it was they changed the names to something like
It's the same with companies with account for Koopman, account. It's like a register for all companies, like a national register. Just saying, I want to know who's stone from TU Delft. Probably doesn't have a private owner, but you can at least see what organization is ownership to an institute or company. That's besides the point.
Yeah, but it's okay. Is there any problem? I think, I'm not sure, I don't know about the organization of this, so I think we use this was for the.
Okay, so when we present it, do we just present more or less ready, or should we add something to the paper?
I think this is fine. We can state that it might not be the most significant ones because it's hard to say which one are the
Very
most.
agile.
There are only three of these.
Okay. Guys, everyone ready? Sentence go on, I'm going to stop you in the middle. Okay, guys, this is fantastic. My students are always surprised about how much I can hear them when they're chatting in class. Actually, I've been listening in on some of your discussions, and they all sound very interesting. So I'm looking forward to hearing what you've done. The way we're going to do this, because we have maybe 20 minutes to sort of wrap this up, is we're going to go group by group. Each group can, the spokesperson can come to the front, another person to hold up the sheet of paper, right? So the group in front can go first. Who's your spokesperson? Yeah, okay, so who's going to hold the sheet of paper? Quite easy. It's easy stuff. And what I'd like you to do is firstly introduce yourselves, just the two of you, just say who you are, and then explain to us what question you were addressing or questions, and what your discussion was. You've got about sort of 2 or 3 minutes each, so it's quite rapid, but go with that. What I will do as well is just blank the screen because you've got writing all over you. Go for it. Right. Group arbitrarily, number 1. Completely random.
Okay, hello everyone. My name is Verena.
My name is Jordi.
And what we looked into today was 3 significant factors to push GeoBIM integration. So the question was the 3 most important ones. We're not sure if these are the most important ones. These are just, because there are a lot of different things you can look into, but these were the 3 things that seemed important to us. So the first thing we thought of was have a working use case, so that there's an example that people can look at and to get an idea of how a project using GeoBIM could look like, and to use that to develop their own projects. Then the other one was to promote interdisciplinary education, so that you don't have one GIS department and one architecture department and they don't communicate, but to bring together people from different departments to exchange ideas and to have workshops, perhaps like this one where people from all kinds of different backgrounds come together and to discuss and exchange. And then the other thing we thought of was to have software that supports data from those kinds of formats, so that you can bring geodata into your BIM software and add information about the surroundings to your building, but also to bring BIM models into your GIS, so you can have more detailed buildings in the GIS world. And if it's not possible to have software that supports all of that, then maybe create more plugins so we can exchange data between the different formats.
So can I just very quickly follow up, because we really don't have too much time, but just your working use case idea, did you have a specific example or a specific use case in mind with that? Any topics or?
For example, if an architecture is planning a new building, he's interested in where the streets are, what the neighboring buildings look like, if they do some kind of shadow analysis, that the people in the new building don't sit always in the dark. And, so gather all this information in the planning phase of the BIM model,
Okay.
for example.
Anyone else got any questions for group 1? One time. question? No? Okay, just in the interest of time, thank you very much, group one. Well done. Round group two. If you leave the paper there, then I will keep it as a note as well.
Yes.
Okay, so just
That's
two.
too small, but.
Okay, you can read it.
I will just read it.
Just two of you introduce yourselves just because of time, unfortunately.
Okay, so
I'm Nick. Yeah, I'm Konstantin.
Okay.
So we tried to tackle all of the questions.
Yeah.
The first question, yes, it wasn't always successful, as you can see, but we tried to do it.
Go for it.
So the first question is the lack of understanding how you can tackle it and why it can be useful.
Yeah.
So yeah, we thought that unique solutions that BIM can provide is the best way to make people to make people interested, because yes, you can do something with BIM, you do something with GIS, but I'm quite sure there are things that would be unique to GeoBIM.
Okay.
So maybe there are questions that you can answer only with GeoBIM.
Do you have any suggestions for how we can find out?
Um,
Put you on the spot. This is called in English. Right there.
yes.
Not really.
My face.
Let's be. Yeah, we have lots of answers.
Yes.
Okay. Right. Okay. Go for it. Question two.
So the second question was how are you going to tackle the lack of skills and the combined GIS and BIM skills? And our answer would be maybe free courses or other, accessible education.
So probably massive online courses, which becomes quite popular now.
Yeah.
And that's exactly what you mentioned, that the new staff skills, probably you wouldn't be able to send a person to university only to study GeoBIM.
Yeah.
And in this case, this online courses might be a really useful thing.
So let's open that one up very quickly. How many people here know GIS? Most of you. Oh, would you do a course on Revit if it was free? Or on BIM if it was free? Hands up. Yeah. Other way around. Pink people. Any pink people? How many of you would do a GIS course if it was free? Okay. That's a good popular idea right there. Keep going. Good one. You have to speed up. I'm sorry, I keep interrupting.
So how can you make BIM and Geo worlds talk to each other?
About the stimulating. We thought that customer, it can be a customer driven.
Yeah.
That if customers would have a demand for GeoBIM, that would stimulate the providers to provide it. Yeah, because we are from a company world. Bigger part of our, we're thinking about the customer driven.
That's exactly why we wanted to have you answer these questions, because
We had a vision, like if you have the BIM and the Geo worlds next to each other, there will be a huge wall in between of them. But there's one common connection, that will be the customer.
Nice one. And that links back to your first idea as well, doesn't it? Right, keep going, just in the interest of time.
So which question is it?
Yeah, 6 about stakeholders.
Yeah, exactly. So
we're gonna
who's the most important stakeholder? That will be the customer, the most important connection.
And it is local authorities and property owners. Local authorities because we work in the Netherlands, and in the Netherlands, local authorities usually responsible for managing all these databases.
Yeah.
So
Local authority people, hands up. You guys are important. Go for it.
And 3 significant factors to push the GeoBIM.
Yes, we have 2.
Well,
You've done well, believe me. Go for it.
Native support for GeoBIM in the mainstream software, that would be really important, I think.
And second, maybe a bit radical idea, but to make BIM modeling, this building information modeling compulsory for any new construction projects.
That would help. Add one here.
Yeah, go for it.
Because if we want being information for the buildings, there may be some legal issues on privacy, so make it some legal.
It's the only way.
Yes,
This is
that's
what Inspire has found out as well. Right, guys, any very quick questions for group 2? Well done for answering all the questions. Thank you very much, group 2.
Yeah.
You've all got neat handwriting, thank you. Appreciate it. Yeah, if you put your sheets over there, then we'll collect them up and write them up. Oh, wow. Okay, in the interest of time, read quickly.
All right. We are group 3. We have deliberation on 2 questions. Who are the important stakeholders to involve? And the question regarding the lack of understanding on GeoBIM. In the first question, who are the important stakeholders to involve? We transform a little bit this question to who is going to pay for it? Who is going to pay for the maintenance of these models? Because it's not only the elaboration of the models and the elaboration of the bridge between BIM and Geo, but in the maintenance and actualization of this. So who is going to pay for this? So it seems that there is going to be a relationship between public and private sectors in the elaboration of that. This is a question that we want to open to the public. City administrations seems to be the entities as well as local authorities that are going to pay for that. And then it was the question, who is going to use these tools? I mean, who is going to use these models? Because we can extract value out of that, and then in that sense, there's going to be a return for the payment. So we can use these models for flooding modeling, for example, for environmental analysis, for terrorist attacks, for sounds and noise maintenance or understanding. So, or solar and shadow, like how it is in Vienna used. In Vienna, we have a participant from Vienna administration. So, in that sense, it seems that the local authorities, in fact, can pay for them because they are going to use this. Is it possible to use these tools or these models for participatory processes? It's also a question that we often. It seems that the participation of universities is very important, not only in the analysis and in the understanding, but also in the elaboration and data acquisition. Therefore, open data is very important because there are different sources of data, so you can also open the data to everybody. So there we jump to the second question, which is regarding the lack of understanding, because it seems that there is an illiteracy in digital aspects. So the role of universities is important, but it should be from the bottom up. So let's say from the younger children, that it should be an understanding of why a 3D model is important. And also from the communities, from the citizen perspective. So bottom-up processes will push the necessity for the elaboration of the 3D. So it can be from the top down that is going to pay, and the administrations understand, but it's also if from early ages the children understand the importance and the relevance of these 3D models, the public will require administrations to create these models. So understanding in the schools and maybe since early ages that we are living in a climate emergency can be explained also by using these 3 models, and how can we adapt or go forward in the future. So in that sense, we formulate here investments seems to be early or before funding. So investment is important. What is the role of communication in developing technologies? Because smart tools require smart citizens. So this was our
Excellent.
Yeah.
I like the schools idea. That's really nice. Any quick questions for group 3? Silence. Group 3, thank you very much. That's really good.
No, please.
Okay, let's start.
So, group 4, go for it.
Beautiful notes are courtesy of my neighbor. He has a very good personality. So we decided we will go with the last question on the list, which was what are the 3 factors? And then while we were discussing, we also realized that these 3 factors are more than 3 factors. So we were getting lots of ideas bounced around.
Typical students, never following instructions.
Also realized that this question holds answer to all the above questions itself, because if you can prioritize those 3 factors, you've answered the above questions in the holistic nature. So we decided we note down all the keywords that were being bounced around in the room. And then in the end, when we had collected keywords, we divided it into 3 categories, which were suitable to encompass all of them. So the first category that we found out was stakeholder engagement, which is our first factor, which includes the knowledge base and that there is a lack of understanding within the stakeholders who use the whole knowledge. So that includes the end users and also the people who can actually push it forward to the end users within academia and within the industry. Even the software developers also do not realize what applications the softwares can have. So that was the major point that came out of there. Then we also had planning and decision making. So the authorities are not aware of how they could use it for decision making. They do not have those use cases very clear to them. Or the people sitting in urban authorities, they are not aware how efficiently all those tools can be used. And I think everybody has pointed out that part, that we need to have use cases for the municipalities to know. And then one very fancy word that came up in the group was standardized workflows. So that is actually bringing everything together into one place. So everybody knows that if you want to push or have GeoBIM integrated into your project within its whole life cycle, there has to be a standardized workflow that you follow. Bringing it in the design cycle, or either you're bringing it in the O&M cycle. So it should be standardized so that everybody knows what's happened. And the awareness eventually increase in that manner. And we include all the stakeholders from the first point. And then the last point was we had a tough time finding the right word. Then it was quantifying end users' needs / demands. So in this, the major factor was how do we bring in the money and how do we create that end market for the GeoBIM products specifically, not GIS or BIM, but an integrated market for the holistic product. So we thought we should have the business case, which tells that if $1 billion is invested, $1 trillion can be retrieved. And also we should include the carbon economy within that point. It's not just the monetary part, the carbon footprint also counts. So that brings about the environmental impacts. And yeah, that was, and also legal push and data production and protection are all important. So when we have policy frameworks, so all that has to be included. Somebody should also speak. No, it's I. Everything.
Can I ask you one? I don't know if you got to this point, but you talked about standardized workflows, which is a nice, very nice term. When you're saying that, do you mean within an organization or more nationally or even internationally? What is your
we could have
another on the spot
like
question?
We were thinking of bringing everybody together so that the use is clear, how to adopt it, either it is being adopted into a design or it is being adopted in an organization itself for all its projects, or is it on the municipality side? So, like we have national building codes,
Yeah.
right?
Yeah.
So that's everybody uses it.
So this
The
is a
authority-
national level.
Yeah,
standardized
it's
workflow.
at a bigger level, at a macro level, and it trickles down to the micro level. Yeah, a standard.
National level standardized workflow that trickles down. Yes, just because of time, I won't ask you guys if you think that will work. It's challenging, but it's an interesting idea. Great, group 4, thank you very much.
The sheet there.
That sheet, please, yes. Who's next? Group 5. Do we have 6 groups or 5 groups? You've got, right? We've seen you last group. Perfect timing. Group 5, come and say hello.
Okay, no what I want to say. But I don't know if I can read everything. Right? First, we talk to each other. We have a problem of common wording between the BIM world and the geo world. And in our group, we have a very heterogeneous group. We have architects, we have engineers, we have from the education side and from the authoritative side. And we are speaking about the same items, but not with the same words. So having a common wording would help a lot, and understanding what is meant by, for example, a geometry in a BIM and the geometry in the geo world. And if we can solve this a little bit, then we can see what we can use from each other. I know what I have, and I can offer it from my geo side to the BIM side. And on the other hand, I'm interested only in some elements of the BIM side to have it in my data set. So first we have to speak to each other. We have to build up a network of all those stakeholders which are interested in the data from the other side. It could be easier to go from the BIM world to the GIS side. That was the common meeting in this group. But you know, they are different. From my side, it's more easier to come from the geo side. Yeah. But at the end, we can concentrate on some elements from each side which are interesting for the other side. It's not important to have everything translated from a BIM world to a geo world, and everything from a geo world to a BIM world. I'm not interested in the modeling aspects within a BIM model, but I'm interested in a few elements from the BIM side. So all those tools we have, they are evolving now to those elephant tools. They can do everything at the end. They should do everything at the end. They should do in a precise way from both sides view, from both sides perspective. But is it really such important? I think some specific small tools would help much more, only if we know what we need from each other.
Great. Any?
Yeah, networking. I said it before a little bit. Networking is one of the most important sides. I can give you an example. We are currently evolving a strategy for a national mapping agency to be the BIM provider for a country. What does this mean? You can only solve this problem discussing with all the people involved, architects, engineers, geo people, authority people, and so on. And at the end, you will realize that you speak always to the same persons. They are interested in each other, and it's not a process for 1 year. it's a process for 10 years and more to come to a solution. Have to add something?
Yep. Questions for group 5? Excellent, thank you very much. Have I missed anybody? No, we're all done. Right, we're actually in perfect time if I can summarize in 2 minutes. Right, guys, thank you very much. Hopefully you enjoyed the discussions. Hopefully you enjoyed getting to know each other a little bit more in a bit of an informal setting. Most of you are back here tomorrow, so you can continue these discussions. I've been scribbling some notes whilst you've all been talking and outlined the common themes that have come out, which are users, stakeholders, and who are the users and what are the use cases, open data, and the importance of open data, and scroll. Finance, money, value, creation is the third one that came out. So these were things that multiple groups repeated. Common terminology and education is the fourth one I've got on my list. I think that kind of summarizes the 4 major things. What I find very interesting when I do these kinds of activities, and I thank you again very much for participating, is also the interesting small ideas that come out. The general problems are kind of known, we've talked about them, but the small ideas that come out of the group today, we have them hopefully clearly here. We'll circulate everything in a few weeks and you can add or correct us if we've got it wrong. So guys, give yourselves a round of applause. Thank you very much. And for those of you interested in use cases, there are 2 examples tomorrow.
Okay, so we arrived at the end of the first day, and thank you very much for participating. I hope you enjoyed, and thank you for all these nice ideas from discussion. And okay, so we are finished, and see you tomorrow. Bye. See you.
If you'd like to give me my pens back, please feel free.
So if you won't come tomorrow in the event, can you leave your badge at the entrance? Just in case.
Okay.
I hope to see you.
These are all.
Thank you very much.
Yes, too.
Lovely.
Thank you to remote people for following us. Bye.